Testing 1 2 3, testing 1 2 3, testing. What's up, a cow says? Andy, good luck, Vucat. Testing 1 2 3. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Yeah, we are teaching Python here every Friday for the past few months. It's been a lot of fun so far. Every 6 episodes we start a new project, mostly game dev related, aimed at total beginners. In this case, we're talking about guys that have never programmed before in their lives. They're guys that have been curious about programming, never actually tried it. Here we are doing our first game together. This is episode 3, though. That means that we're looking at some relatively advanced concepts compared to episodes 1 and 2. Episode 1 was, what is a program? How do I download and install Python? How do I write programs? These very, very basic type stuff. Last time we covered some more in-depth on episode 2. We covered some more logic blocks, some more code blocks, logic trees. As you can see, our program here is, relatively long now. In the grand scheme of things, it's a very, very small, very simple program that anyone can write. And if you guys go back and watch episodes 1 and 2 for total beginners, you'll definitely get the hang of this, no problem. We have 108 lines right now. Again, very, very short. As you can see here, there's lots of indentation going on, lots of code blocks, lots of logic, which means that are kind of getting a little bit messy here. Also, some very long lines here. See, it's going all the way off to the far right of the screen in some cases, which is kind of hard to read. So today our goal is going to be to use functions, to learn how to define our own functions, to make this a lot cleaner and easier to understand, easier to break down. Functions allow us to break large, monolithic pieces of code that are just one big chunk, break them into smaller, more bite-sized pieces that are much easier to digest. In the chat, I got some guys talking to me. Vucat says, we'll be back next Friday. Okay, well, good luck with your studying, Vucat. A cow says, what game? You're talking about MK11 in the chat here. Here goes, it's really excited about that game. Isn't that game coming out really soon? It's like a pretty late beta. Nuke says, I'm going to go into the principles of IT next year, so the stream will help me out a lot. Hoping to be a game tester. Is this series on YouTube? It is indeed Nuke Pool. It is indeed in its entirety. That's the Intro to Python playlist on YouTube. There's a big playlist there. I think it's called Intro to Python or Learning the Program. Just go to youtube.com/Vencabot archive, and you'll find all of my playlists there. It's the very bottom in the non-gaming playlists. We have, this is season 4? This is season 4. So we've had, our first season was 6 episodes of Pokemon, learning how to do Pokemon, make a Pokemon battle, that is. Season 2 was a Zork-like adventure game. That was sort of like a puzzle game where you explored a cave and tried to find items and use them to unlock doors and stuff. That was fun, 6 episodes, starting off at, the very basics of what is a program and ending with a fully working game. And then the next series was a JRPG, sort of like a Dragon Warrior, where you went around and fought monsters and you got gold, you could spend the gold on buying weapons and that kind of thing, and potions. And that was, again, 6 episodes, starting off with the very basics of how to download and install Python, how to write your very first line of code, and then ending episode 6 with a pretty cool game, I think. We're pretty well on track for this one, too. Episode 3, our game's already pretty fun. We have a little virtual pet. Let's actually try it right now from last time. So it says here, what is your pet's name? I'm going to name him Vucat, in honor of my friend Vucat, who's studying tonight. Do you want to feed or play with Vucat? I want to play with Vucat. It says Vucat's too hungry to play. Vucat seems kind of hungry. Okay, I want to feed Vucat then. What do we want to feed him? We can feed him anything we want. Our digital pet has a favorite food, which is potato slices. Right here. And a most hated food, which is orange. Does not like orange. I like potato slices though. Let's give him some of his favorite food. Potato slices. Okay, so he ate the slices, but he still seems kind of down. So the way our game works is that basically you can manipulate your pet's happiness by feeding it things that it likes, things that it hates. And whenever it says here, they seem kind of hungry, that means that their hunger meter is so high, they're so hungry, that they're losing happiness. So you have to feed them enough that they can kind of be, satisfied, and then also hopefully feed them something good enough that they are more happy because of it, right? The guy, he really likes he really likes potato slices. I'm going to keep feeding him that. Potato slices. Okay, so now he seems in high spirits. Okay, so now he's more or less happy. So now we can probably play with him, huh? Let's play with Vucat. What do we want to play fetch with? I want to play fetch with a ball. Okay, so he watches the ball fall and looks at you dumbly. He seems kind of hungry. So basically, the more happy he is, the more excited he is to get the ball for you. He just watched the ball fall down and looked at me dumbly. That means he's not really that happy. And he still seems kind of hungry now. All right, let's feed him again. Let's feed him something that he doesn't really fall in love with, though. Let's feed him like an apple. Right? He neither loves nor hates apples. Right. So he eats the apple. He seems kind of down. And that's because when he eats his non-favorite food, he loses a little bit of happiness. So he only really likes one kind of food, which is his favorite food. And if you feed him his most hated food, he gets really upset. And if you feed him food that's kind of like in the middle, he doesn't really care about, he gets a little bit down. Yeah, I'm really enjoying this game so far, Cow says. I wasn't sure how it would pan out for the stream, but it's been working pretty well. Let's feed him again. I'm going to feed him some potato slices to make him happier. He's back in high spirits again, but he probably still just want to play fetch. Let's feed him one more time. This is where things get a little bit interesting, I think. Feed potato slices. Oh, okay, so I guess not quite yet. Let's do it one more time. Still in high spirits. Feed potato slices. Okay, so now he's ecstatic. Right now he's ecstatic because he's his max happiness, more or less. He takes a massive dump because he reached his max fullness. So once your pet becomes full, it'll take a shit, and then that shit is on the ground. So now we can feed or play with VooCat, or we can clean the room. Right, we have these three options now. And if we don't clean the room, his happiness declines much faster as long as there's shit in the room. Let's go ahead and clean it then. Okay, so I clean up VooCat's poop. Right now he seems kind of hungry again. So basically, he has a fullness bar, essentially, or a hunger bar, that maxes out at 100 if he's really, really hungry. Once it's 0, then he takes a big shit, and then he's really hungry again. Right, and that's kind of the cycle there. So the challenge of the game is to sort of maintain his happiness level while also sort of keeping him well fed and stuff, and cleaning up his shit. It's not that hard of a game right now. It's not that interesting really mechanically. It's more of a exercise in programming and logic, right, to have this all work correctly. But really as a game, it's not that hard to keep him happy. Just feed him potato slices all the time. That keeps him happy. Hey, what's up, Philip? What's up, Steve? Welcome aboard, guys. So yeah, so the game is pretty simplistic. Once he gets upset enough at you, I'm going to feed him some of his most hated food. Right? He's mad depressed now and seems kind of hungry. I'm going to feed him an apple right now might actually put me over the edge. There it is. So once he gets down to 0 happiness, he bites you and then poops on the carpet, and then you faint from embarrassment, and then it's game over. Right? It's basic, yeah, very good beginner's program. Right? Once you get to 0 happiness, he bites you, he poops, and then you faint, and it's game over at that point. So let's go look at how our game works. Right? Again, it's a little bit more than 100 lines. Less than 100 if we removed all these blank lines are there just to make it a little easier for us to read. Right? We learned in Python how blank lines like this have no meaning in Python. They're very, you could have 100 of them, and your program would work just the same. Or you could have none of them, and it would work just the same. Right? But it's easier for us to read sometimes with these blank lines. That's why we use them there. So I'm trying to break up things, you know, kind of logically. Yeah, Steve, we got like a little virtual pet. We won't call it a Tamagotchi clone. We're kind of making it more like a game, right? Because I tend to think in terms of games. The goal was to make a virtual pet, and maybe over time it'll become more like a virtual pet. But it really plays out more like a game. Anyway, so we have this. The start of our program, we define some values. We learned in our very first episode for the season that every program consists of attributes, data and operations. Right? Every program is operations that do things, right? That make your computer do things, and then the data that it needs to get the job done. Right? So in this case, we have some data defined right up here. We have the pet's favorite food, which is potato slices. We can change that to whatever we want. We have the pet's hated food. We have the pet's happiness, hunger, and the poop on floor value. And here we have these data types, right? We only know of 3 data types right now, I believe, so far in episode 3. That is strings, which are text, right? We have these names for these values. Here's a name for the string. Pet's favorite food. We assign that name with the assignment operator, the equal sign. And then we assigned that name to a value, which is this potato slices string here. Then we have this other name here, pet's hated food, also called a variable. Equal sign means we're assigning some value to that name. We're assigning the string orange to the name pet's hated food. Okay, here we have some integers, right, which are numbers. We learned before that strings are usually for showing some text to the user. They are textual data, and then numbers, integers, can have math done to them. So we actually add and subtract from the happiness and the hunger. And as you might imagine, as you've seen how our games work so far, that's pretty important, right, to add and subtract to the happiness and the hunger meter. The Dark Souls of pet maintenance games. Yeah, I think that Tamagotchi is more like a toy than a game. Just needs a GIF trigger, a GIF trigger input, or a PNG style display. GIF trigger? I should understand. Anyway, we have the pet's hunger as well, also an integer. And finally, our last type of data is a Boolean. So we have strings, which is text, integers, which are numbers, and we have Booleans, which are true or false. They're a very simple data type. Booleans are important for logic, right? So if you say, if this is true, then do that, right? Or while this is true, keep doing this. And so we need to have Booleans, like true or falses, to make that work. Okay, so the very first thing we do after we define all of our data here, the very top of our program, is we ask the user for some input. right? We say, we call the input function, the built-in function input, and we say, what is your pet's name? So here's our first function call of our program. So a function is a bit of code that runs behind the scenes, right? We're not showing the code here how it works. Right? Up here, we're showing how things work. And down here, we're showing how things work. Right? But here, input, something is happening. We don't know what it is, how it's working behind the scenes. We just know that it does work. So there's input function here. And we're calling it by using parentheses. So when you call the function to make it work, you use its name, and you follow it by parentheses, such as right here. Print, that's a blank line right there. It says print a blank line. So we have this function print, and we're calling it by putting parentheses after it. Same with input here. But also, between the parentheses of a function, you can supply some, what's called an argument, or some data that function can use to do its job better. Right? So here we're supplying an argument, which is a string. What is your pet's name? Now the input function uses its first argument to prompt the user. So in other words, we're getting some input from the user, and we're asking them, what is your pet's name? It's a pretty interesting function here, input. Right? It has all the makings of the sort of functions we're going to be making ourselves today. Right? Today we're going to make our own functions finally. But another thing that functions can do is they can return a value. So you have this input function, and you're calling it with the parentheses, and between the parentheses you're supplying an argument, which is the data that it uses to do its job, but also when a function is done working, it can give you back a value. And here we have the equal sign saying whatever value is returned by input, save it to this value pet's name. Right? So input is doing its job using the argument, what is your pet's name? And then when it's done doing its job, it returns a value that we can then save, right, to a name, in this case, pet's name. So input is a function that returns whatever value I type in, right? It asks the user to type in something, you type it in, you press enter, and then that value I typed in is returned. So pet's name can be whatever I want it to be, in other words. Let's run that code to kind of get a feel for how it works. Right? So the first thing we see as a player is what is your pet's name? That's because up here we have these assignments that happen behind the scenes in the program, right? The user does not see this stuff, but we as programmers made it do all this assignments here. Right? So all that shit gets done right off the bat. Programs flow from top to bottom, so these things happen first in order. Right? All these assignments to these names. Then the first thing we see is what is your pet's name? Right? So this is the function call for input. I'm going to punch in Steve and press enter. Okay, it says, do you want to feed or play with Steve? So what happened here was that I pressed enter, and then input finished doing its job, and it returned that value that I typed in, Steve. And that value got assigned this name, pet's name. Right? And that's why down here, we get to get this input, we get this prompt. So we call input again here. Do you want to feed or play with pet's name? Right? Do you want to feed or play with pet's name? So what we saw was, do you want to feed or play with Steve? Because pet's name was assigned to Steve right here. When we type that in. Hey, what's up, Nordis Power? Yeah, so we have this, after we have the input for the pet's name, we print a blank line, which we saw right here. Right? See, there's a little blank line there. Breaks it up a little bit, makes it easier to read for the player. Right? And then we get into this while loop. It's a little bit more complex. So let's one more time review the very first few lines of our code. We assigned some data to some names. So we can use these names later in our code, like pet's favorite food, pet's hated food, pet's happiness, pet's hunger, and poop on floor. And then we have this pet's name as well we got from the player using the input function. Right? Input returned whatever the player typed in. We saved that data into this pet's name. We print off a blank line, right? And now we're in the main loop of our game. This is a while loop. This loop will keep on going forever, right? Or so you would think. So basically, a while loop is a type of code block. Right? We talked before about code blocks, how code blocks are a little bit different from other parts of your program. Where in the first few lines here, our first, 8 lines or so, our code is flowing strictly from top to bottom. Right? All these lines get run in order. Okay? But once a line is indented, and the preceding line has a colon at the end, like this, see that colon right there? We have indented lines. That means that we're in a code block. And code blocks are really, really interesting and very, very important to making interesting programs because they help you run code in a non-linear way. Right? So now this code is not going to be going from top to bottom necessarily. It could run in some other kind of crazy way that we only understand as programmers if we know how a while loop works. Right? So here's our while loop. Every code block starts with a definition for that code block. right? So here's the definition of the code block, while true. And that line always ends in a colon. Anytime you see a line ends with a colon, and the next line is indented, that means that the first line is the definition of the code block there. So here's while true, that's our definition for our code block. And then here's the code block itself. The code block goes on until we stop indenting. Okay, so here we have 4 lines of indentation, right? We're gonna go, this while loop is all these lines, right? Keep on scrolling down until it stops indenting, right? Keep on scrolling down until it stops indenting. Okay, all these lines are still inside that while code block. Okay. Then you write down here, see print game over? That's outside of the code block. So this is our entire code block right here. That's the entire while code block. That's all indented. Okay, so that's all inside of this while block. All right. It says while true. So many code blocks have a condition that will define how that code block works. And that condition is usually a Boolean. So here we have a Boolean true, while true. So the way while works is if the Boolean value after the word while is true, then it will run repeatedly. It'll run again from top to bottom. So in other words, what's happening here in this while block is that all this code is running. All this code is running here. And then when we get to the very bottom of our code, right here before the game over, is the bottom of our block right here, right? Once we get down here, we go back to the top of the while block. And we say, well, is the second half of the while definition still true? Now, oftentimes you would have a value here like, you know, pet's happiness greater than 50. Right. So in other words, what this means is that as time goes on in the while block, if this value is changing, right, if pet's happiness is changing, this might not always be true. Right? It might start off as being true, but at some point it might not be true anymore. So we go back to the very top of the code block after we hit the bottom of it, and we ask again, well, is pet's happiness greater than 50? If that's true, then run it again, and then do it again. Go back to the very top and ask again. You know, is it still true? As long as it's true, keep on looping over and over again. Right? Now, what's crazy is that today we have this while true. So true is always true. It's not really there's no condition there. There's no question being asked, like there oftentimes is for a Boolean. Here we just have a raw Boolean literal. Right? A literal is like a raw piece of data. Right? It says right there, while true. We have a true literal. Right? That means this while block's going to always run forever unless we forcibly kill the loop somewhere inside of it. And if then and goto loops in this, is there any? There are if then. We have one right here. It's called if else in Python, or we have a if block and then an else block in Python. And we don't have gotos. We do have functions though. Goto is a feature of BASIC. Something like a Kaus is familiar with BASIC programming. And in BASIC, you don't really have functions per se. You can have gotos instead, and functions are kind of similar. Anyway, so we have this while true, right? This means while true, and true is always true. It means forever loop over this, right? The first thing we have inside of our code block is another code block. Right? Here's another code block, right? It's an if code block. Right? Here's the entire one, because we talked about how the code block keeps going until we stop indenting, right? So right here, the else is the same indentation level as the if. So the code block is only one line long, right? That's your code block right there. So it's a one-line code block. It says here, if not poop on floor, which means we have a poop on floor value, right? It's false. And not means reverse the value of the following Boolean, right? So poop on floor is a Boolean, it's false. And not reverses its value, right? So if not poop on floor, and poop on floor is false, that means if true, right? And just like while, a true block will run if the following condition, you know, after its condition is true. Right? So this is true, right? Not poop on floor. Because poop on floor is false, and not reverses it. So poop on floor is false. If not poop on floor, then very simply ask the user if they want to feed or play with their pet. Else is the next code block, and else means run this code block if the previous if did not run. Right? So if the previous if did not run, then run the else instead. If not poop on floor, do this. Otherwise, else means otherwise, do this. Right? If not poop on floor, ask them this question. Otherwise, ask them if they want to feed or play or clean the room. Right? See how that works? It says here, do you want to feed or play with or clean the room? That's because we asked here, if not poop on floor, if there's no poop on the floor, then simply ask, do you want to feed or play? Else means if there was poop on the floor, then ask them, do you want to feed or play or clean the floor? Because we know there's poop on the floor, right? So a very simple little code block, a pair of code blocks here, right? The if-else pair. The first one asks, is there not poop on the floor? Then do this. Otherwise, there is poop on the floor, then do this. As we kind of change the wording of how we ask the user to choose their options if there's poop on the floor. Right? And likewise, we have this input, same kind of input pattern as for when we ask for the pet's name, Steve. Right? Where we use the input function. It's built into Python. We didn't write this function ourselves. It's built in kind of like print. Yes, everyone can always use it. And we asked a question, just like with our first question here. Use the argument of the function is the prompt the user sees. Do you want to feed or play with Steve? Right? And then it returns a value that we save as pet activity. Right? So pet activity is going to equal either feed or play. Whatever I typed in is going to get returned and put here as pet activity. Right? And then same with this one here. All we do is we change the prompt if there's poop on the floor. Right? Depending on if there's poop on the floor or not, we change our prompt to include the option of cleaning the room. Okay, so once we've got our pet activity from the user, we've saved this value, right? We saved it to this name. We print another blank line, right, to make things a little bit easier to read. And then we start saying, okay, well, if the pet activity the user typed in, right, we saved that right here. If pet activity is equal to feed, then do this. Once again, another code block is another if block, right? And it goes on until it stops indenting. Let's get this entire code block highlighted. So here's where it starts, right? If. It's the same level of indentation as, print and else and if, right? But it's still inside the while block, right? We have code blocks within code blocks. It's still within while. You can tell because it's indented by 4 spaces, right? 1, 2, 3, 4. So all this is inside the while block, right? This stuff inside of the if block is indented by even more, right? It's got 8 spaces of indentation. So once this stops indenting, we'll know that our if block here is complete. So let's highlight the entire if code block here. This code block exists inside of the while block. Let's see. Right there it ends, right? Right there it ends. Because it's where we started our indentation level at. So here's the entire if code block, right? So it says here, if pet activity equals feed. So it stands to reason then that this code here is the code for feeding our pet, right? All this entire block is for feeding the pet. Okay? Then it says down here, elif pet activity equals play, or is equivalent to the string play. We have another kind of code block here. We know about while code blocks, and we know about if code blocks, and we know about else code blocks. Here's our final code block we've been learning, which is elif. Elif is a combined else and if. It's what's called syntactic sugar in Python. That just means that its job that it does is not distinct in any way from another piece of code. It's just prettier. Right? That's syntactic sugar. Syntax is another fancy word to say grammar. We're talking about a language, right? Python is a language. So every language has syntax or grammar. So syntactic sugar just means it's a prettier form of grammar. So elif replaces an else followed directly by an if. And here's why. Because we could do it like this. We could just say else if pet activity equals play, then we could actually indent this even deeper. We would have to, right? And that can cause a lot of ugliness in your code. It can cause you to have to indent things very, very deeply over time. That's why we have elif. Elif combines an else followed directly by an if into one code block, which means less indentation. That's why it's syntactic sugar. It's exactly the same as else followed by if. It's just that you do it on a single code block, which means less indentation for you. So let's see what we're asking here. We're saying, if you want to feed your pet, run all this code, right? Then we're going to say down here, else if, right? Otherwise, if you want to play with your pet, then run this code. Let's go down that entire block. This entire block ends right here. You see where it stops being indented right here. Right? Then we're saying, otherwise, if you want to quit the game, then do this. Otherwise, if you want to clean the room, then do this. We have a cheat code here as well. Otherwise, if you put in dagger, then you get a cheat code where you get your pet's happiness to maximum right off the bat. Right? And then finally, it says here, else. Right? So we have a code tree here, a logic tree, that says if, elif, 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 else. Right? So we're saying here, if this is true, then feed your pet. Otherwise, if they want to play, then play with the pet. Otherwise, if they want to quit, well, then quit the game. Otherwise, if they want to clean, then clean. Otherwise, if they want a dagger, that's a cheat code. You know, yeah, they get the pet's happiness up. And then else means if none of the above were true, right? Because else only runs if the preceding if was not true, right? Let's kind of go through that one more time. I apologize. It was a little bit, if you're a non-programmer, it'd be kind of weird to understand. But yeah, so here's the first if, right? If we want to feed the pet, run this. And then the else block, if that wasn't true, then the else block will run, right? We learned about the pair, the if-else pair. Else will only run if the previous if did not run. So if this is true, do this. Then on here we say else, right? And then another if. So if that wasn't true, then ask another question, right? If they want to play, then do this. Then if that wasn't true, this else runs, right? This elif runs. So else, if that wasn't true, well, then ask this question. Was it quit? Okay, well, it wasn't quit. Well, then was it clean? Okay, well, it wasn't clean. Well, was it dagger? Okay, well, if it wasn't dagger, then we know it wasn't anything we recognize, right? It was not anything that we know how to do. So it says here, else, just print off, please either feed or play with the pet or clean, right? That's all it does. So that final else block is like, okay, you typed in something. I don't recognize what you typed in. It wasn't any of this stuff that I know how to do, so, you know, please enter something I know how to do. If I typed in this thing right here, if I typed in, you know, bananas right here, it would say, please either feed or play with Steve, or clean or quit. Right? So, in other words, it doesn't know what to do with bananas, right? It's not really a thing you can do with Steve. Yeah, it's kind of like C++ a little bit, right? That's another programming language if you guys are total newbies. It's a lot like Python, but nowhere near as cool. Okay, so let's look at our code in a little bit more depth here. Right? We have this big if, elif tree where we broke up our code into things you can do with your pet. Right? So how does feeding work? Well, feeding is quite simple. It asks you what kind of food you want and saves it. Right? Here's the input again with the prompt, which is the argument of the function. Right? Get some input. We save it as pet's food. Whatever you typed in becomes the pet's food value. Then it says here, if pet's food is equivalent to. Now we learned that the single equal sign, right here, that's the assignment operator in Python. That means that whatever value is on the right gets the name on the left. It assigns a name to a value or assigns a value to a name. Either way you want to look at it. It just saves it, right? That's what equals does. Equals is different. This is a comparison operator. It compares two values and gives you a Boolean back. It means is equivalent to. If pet's food, you typed in, is equivalent to the pet's favorite food. This value is evaluated, right? This statement is evaluated and gives you back a Boolean value. We learned that in many code blocks like if and while and elif, the Boolean that follows the the definition of the if, that value determines, it's a Boolean and determines if it runs or not. If it's true, it runs. If it's false, it does not run. So here's our Boolean right here. It's not a Boolean literal, right? We learned that a Boolean literal is when you type it out very plainly, right? That's why it's called a literal. While true, that's a Boolean literal. This is not a Boolean literal, but it's still a Boolean, right? Because this value here, pet's food is equivalent to pet's favorite food. It does give you back a true or a false, right? It's still a Boolean. It's just not a Boolean literal. This is a comparison. So if you typed in the pet's favorite food, right? If the value we saved here from your typing is equivalent to the pet's favorite food, well then the pet's happiness goes up by 20, right? Plus equals means increment this value by this number, right? So pet's happiness started off at 50, right? We can look up here, right? We have these values already. The pet's favorite food is right there, potato slices, and the happiness is right there, 50. So if whatever you typed in is equivalent to potato slices, then increment the pet's happiness by 20, plus equals. We can also do this another case of syntactic sugar, right? The same thing as doing this. Pet's happiness equals whatever pet's happiness was plus 20, right? So we're making a value called pet's happiness, and we're making it equivalent to whatever it used to be, pet's happiness. We defined it right there, 50, plus 20, right? So the new value for pet's happiness is whatever it was, plus 20. But in Python, you have a syntactic sugar to make that a little bit easier to type. You just say plus equals. That just means take whatever it was and increase it by 20. I could put in period, feed, anything other than orange or potato slices. Give you a text stating what types of food is available or it can eat. It's a good idea, Cow says. We could definitely do that. Right now, our code, the way it works, is that if you type in a food it doesn't know, then the pet's happiness, it'll eat it, but it'll lose a little bit of happiness. Right, so if we look at our code right here for feeding the pet, it says if the pet's food you typed in is the pet's favorite food, it's equivalent to it, then we add 20 to the happiness. If it says if pet's food is the pet's hated food, then subtract 40 happiness. Right? If pet's food equals rocks, then print don't do that, you meanie. Right, that's really all that does. It doesn't eat rocks. And then it says otherwise, if it was not the favorite food, and it wasn't the pet's hated food, and it wasn't rocks, then we say else pet's happiness is, minus 10. So it'll eat anything, right? I can feed him right now. Watch, feed. I can feed him, an apricot. He'll eat it. It says here, Steve eats the apricot, and he seems kind of down. So he will eat the apricot. He doesn't know what it is. He loses a little bit of happiness, but he will eat it. And what a cow says is we could actually give it, instead we could say this. We could say else, let's change our code right now, in fact. Else, print, please feed Steve. Oh, we'll say you only have, right? You only have, plus pet's favorite food, plus pet's hated food, plus period, right? And then continue. I'm going to tell you guys what that means in a second here. Okay, so we changed the way that our code works now. Before, it would eat anything, right? And it would lose a little bit of happiness. But now instead, it won't eat, it'll only eat favorite food and hated food, and it won't eat rocks either, right? Let's save this. So now it won't eat the apricot anymore. Let's restart our program. Go up here to run module. Okay, so what's your pet's name? Steve again. I want to feed Steve. I want to feed him the apricot again. Okay, it says here, you only have potato slices and orange. Then they ask the question, do you want to feed Steve? Yeah. I want to feed him a tire. Okay, we can only feed him potato. Yeah, I only have potato slices and an orange. Right, so that's kind of how our code works now. Whereas before, it would just subtract happiness. Right, a little bit different. I'm going to actually go back to the old way of doing it. I just wanted to demonstrate how that works. Right. So basically, we have this if-else tree here. Pet's happiness minus equals 10. We have this little logic tree that says here, it kind of asks, what kind of food is it? Right? If it's this, then do this. Otherwise, if it's this, then do this. Otherwise, if it's rocks, then do this. Otherwise, whatever it is, just subtract happiness at that point. Right? If it's something I don't know what it is, subtract a little bit of happiness, no big deal. Not as bad as the pet's hated food, but he's not happy about whatever he's fed him. Okay, so then we get this print statement here. After we fed our pet and it shows how much happiness to remove, it says here, pet's name plus eats the plus pet's food plus period. Let's go and demonstrate that. Run the module. Pet's name is Steve. I want to feed him potato slices. Oops, I'm sorry. I wanted to feed him potato slices. Okay, so let's see here. Steve eats the potato slices. Right there. Steve eats the potato slices. That happens right here. Right? After we subtracted his health or his happiness, and we raised it if it was his favorite food. Right? After this runs, then we print off pet's name. That's Steve. Plus eats the. Right? You can see that right here. Then we add in the pet's food, and then a period. Potato slices, period. Right, so it comes out as Steve eats the potato slices. And we're doing what's called concatenation here. The fancy way of saying addition. Right? But when you concatenate things, or concatenate them, I'm not sure how to pronounce that, you combine them like this. You squeeze them together. Right? So Steve is concatenated or combined with eats the, and that's combined with the pet's food, which is combined with a period. Right? And that's different from addition, like mathematical addition, right? In math, we do it right here, right? We have a value of 50, pet's happiness, and we're adding 20 to it. Right? That becomes 70 then. It does not become 5,020, right? That'd be a concatenation. That'd be squeezing them like this, side to side. Right? That'd be, 50 plus 20, that would be 5,020, right? 5020. But we're actually adding them mathematically here. So when you have a plus sign between two numbers, they get added mathematically. But if it's between two strings, like our pet's name, and the string eats the, and the pet's food is also a string, that concatenates them. It makes them get combined, right? And that's why you cannot add strings to numbers, because numbers are only for math, and strings are only for showing people, right? And that kind of thing. So they have different ways of adding. So you cannot add, let's say I want to say, Steve eats 50 apples, right? Well, I can't add in the number 50. I have to add in a string for 50. And that string would be a 50, right? It would be 2 characters, the character 5 and the character 0. It wouldn't be like a mathematical number as far as Python is concerned, right? Now, the user as a human being would read that as a number, of course. But, you know, we can't, it would have to be a string. It would not, internally in Python, it wouldn't be a number, right? It would be 2 characters, a 5 character and a 0 character. It wouldn't be the actual number 50. You guys see what I mean? It's kind of weird, I know. We'll talk more about that later. In any case, so we have, you know, we printed off that they ate the food, and now we print off, you know, Steve seems in high spirits, right? So after that, we do some calculations, right? We would do some more testing. We say, okay, so we just raised or lowered the pet's happiness, right? After he ate, we raised or lowered his happiness. So we're saying here, okay, well, if his happiness is greater than 80, or equal to, right, greater than or equal to 80, then print off that Steve seems ecstatic. Otherwise, elif, or otherwise if the pet's happiness is greater than or equal to 50, right, so it's not a 80 or above. Okay, well, is it 50 or above? If so, print off they seem in high spirits. Okay, well, if that's not true either, right? Otherwise, if, okay, well, it's not above 80, it's not above 50. Well, is it above or equal to 25? If so, print off they seem kind of down, right? Because we know it's less than 50, but more than 25. Otherwise, print off they seem mad depressed. So at that point, we know it's not 25 or higher. It's something pretty low. So if it's really high, print off they're really ecstatic. If it's kind of high, print off they seem in high spirits. If it's kind of low, print off they seem kind of down. Then if it's not any of the above, it's got to be really low. Print off they seem mad depressed. Right? So we're not going to tell the user exactly what the pet's happiness is, but we will kind of imply it with this message here. Then print another blank line, make it easier to read. Right? You can see the blank line right there. And then subtract some pet's hunger. So basically here we're saying the pet ate some food and he got a little bit less hungry. Right? So he got, his hunger level was at 50, now it's at 30 or whatever. We subtract 20 from his hunger after he eats. And finally, we say here, if the pet's hunger is less than or equal to 0, so if he's completely full, if he has no more hunger left, then print off, he takes a massive dump, print a blank line, and then change the poop on floor value from false to true. Right? Because it started off as false, right? Poop on floor was false. Now it's true if he took a big dump. Then pet's hunger goes back to 100. Right? He's hungry again. So at the very end of our feeding session, if he's completely full at this point, then have him take a shit, change the poop on floor value to true, then make him hungry again. That's kind of how our game works for feeding. All right, so now we know about the feeding code. That doesn't explain why, at the very end of our code here, we could ask, it says here, Steve seems kind of hungry. When did that happen? Not in here. Well, it happened at the very end of this while loop. Right? Just go over to the very bottom here. It says here, if pet's hunger is greater than 70, right? If its hunger is more than 70, print off that they seem kind of hungry. And then remove some happiness. Right? Because he's hungry, he's starving, he doesn't feel good. So he's a little bit less happy if he's hungry. All right, so here's the thing, right? We jumped down from the feeding code to this line, but why? There's a whole lot of lines between, right? We fed him, he seems in high spirits, then all of a sudden he seems kind of hungry. Well, I mean, this line is right down here on line, 96. And up here, we subtract, this is on line, 44. So what happened to all these other lines in the middle? How come they didn't get run? Well, because they're parts of these elifs, right? There's code blocks. Code blocks, we explained earlier, they don't always run top to bottom. We learned up here, if there's no code blocks, this code always runs line by line, 1, 2, 3, 4, 5, 6, 7, in order, top to bottom, right? But code blocks don't always run. They run on a condition, right? This line right here would not run if there was poop on the floor, right? That line would be skipped if there's poop on the floor, right? So right here we say, if they want to feed their pet, run all this code, right? Then it says here, otherwise, if they don't want to feed their pet, but they want to play with them, run this code. See what I mean? This code will only run if they didn't feed their pet. We did feed our pet. This code gets skipped. Same with this. If they don't want to feed, but they want to quit instead, then run this code. Well, we already fed them, so we already noted that, so we skip this part. Same here, skip this part too. And this part. All this code gets skipped because we fed our pet, right? Only one of these things can happen. So it's a big if, elif, 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 else tree. Only one of these actual code blocks actually happens. The rest are skipped. So if they want to feed the pet, run this code. Otherwise, if they want to play with their pet, run this code. Otherwise, they want to quit, run this code, etc., etc. All that code is skipped because we fed our pet. So it goes right down here to this line and says, if the pet is hungry, then print off they seem kind of hungry, make them a little bit less happy. If there's poop on the floor, then subtract even more happiness. And finally, if the pet's happiness is 0 or less, then say it bites you, print your favorite embarrassment, and then break. So what is break? Well, break is a single line of, it's a single statement in Python that simply says, if you're inside of a loop of some kind, end that loop. Right? If you're in a loop, just end that loop. So we looked before at how we're inside of this while true loop. So as long as we don't break out, it's going to run forever, right? Because it's while true. Normally you'd have like a while and a condition. But there's no condition here. The condition, it just says true. So it means run forever. So we're running forever until we break out in some unnatural way. So normally if the pet was, above 0 happiness, we'd go back to the top and then ask again, what do you want to do? And we see that right here, right? We fed our pet. He's fed now. And then it asks us again, what do you want to do with Steve? That's kind of our loop. The loop of our game is ask what you want to do, and then do it, and then ask again, what do you want to do? And then do it. Do it over and over again, right? That's kind of how the loop works. But if we have 0 happiness or less, then we break, which means exit the loop forcefully, right? And that says game over, right? That's exactly how this works. So if you get to 0 happiness, then we kind of faint from embarrassment. We break out of the loop. The game ends and the program ends. There's no more code down here, right? That's it. There's no more. We're not in a while loop anymore. There's nowhere else we're doing. We're done. The game ends. I can do that right now, in fact. Let's just feed him some oranges. Right. Boom. Right. Steve bites you and then poops on the dang carpet. You faint from embarrassment. Game over. Right. So pet's happiness got below 0 at this point. So this line triggered. This block got triggered. Prints off that I got bit. I fainted. We break out of the loop, which means we finally get down here. Game over. There's no more lines of code, which means the program ends. Hey, what's up, cool hand? We also break out of this if you type in the word quit, right? So it says here, if you want to feed the pet, run this code. If you want to play with the pet, run this code. If you want to quit, then it says pet's name goes back to bed, and then it breaks. It ends the loop, right? So then it's game over. Let's try that. Run the module. I'm going to call this Coolahan. We're going to feed Coolahan some French fries. Okay, he's not too happy about that. It's whatever. I'm going to quit. Coolahan goes back to bed. Game over. Right? So it breaks out of the loop right here. We type in the word quit. Right? Breaks out. We go down to the very bottom of our code. Game over. Gets printed off. The Coolahan loves fries. Let's change our, our favorite food then to French fries. There we go. Now we type in the word French fries in our game and make him very happy. It's going to match that, right? It has to match whatever our favorite food is, and he gets really happy. Okay, so we also have this little code here for playing with the pet. All it does here is, if he's not happy enough to play, right? If pet's happiness is greater than 50 or equal to 50, then you can play with the pet. Otherwise, it says he's not in the mood to play. Right? Here's the if, and then here is the paired else. Right? You can tell because it's the same indentation level, right? All this code here is inside of the if block. Sorry. All this code is inside the if block. You can tell because it's all indented, right? Kind of hard to see my cursor there. It's all indented, right? Here's where the if block ends. Here's the last line of it. Then here's the following else block, the paired else block. Right? This code will run if that first line did not run. 2 favorite foods, huh? We can talk about that in a minute. We'll talk about some lists later on. That's actually a pretty good idea. Okay, so we have, we'll do that right now, in fact. Yeah, that's a pretty good idea. Let's do this. We'll say pet's favorite food 1 is French fries. Pet's favorite food 2 is pie. Who doesn't like pie? Right. So we're going to have 2 favorite foods now, right? So we go down here to our feeding code block. It says here, if pet's food that you typed in is equivalent to the pet's favorite food, increase happiness by 20. That's what it does. But we have 2 kinds of favorite food now, right? Why don't we say here, if pet's food is equivalent to pet's favorite food, 1, then increase by 20. Then we can say here, if pet's food is equivalent to pet's favorite food 2, so there wasn't the first one, but it is this one, then say pet's happiness plus equals 20. There you go. Now you have 2 kinds of favorite food, right? They both do the same thing. But, if they both do the same thing, it seems kind of redundant to have it be over 4 different lines, right? So why don't we change this to say, let's get rid of this line here, this block, and just say here, if pet's food is equivalent to pet's favorite food 1, or pet's food is equivalent to pet's favorite food 2, do this. So now we have compound statement. Right? We have this or, this little or statement there, which will sort of combine these two comparisons. Right? If this is true, or this is true, do this. Right? That's when we get the job done. Now we have more than one kind of favorite food. What's up, Kenny? Right? But there's a little or statement there. If one of these is true, then do this. Right? If one is false and the other one is true, then we can do this. That's one way to do it. But hopefully, maybe even by the end of tonight, we're going to talk about lists, which are actually a new kind of data type for us. We know about 3 kinds of data, right? We know about strings, integers, and Booleans, and functions, technically. So that's actually 4 kinds of data. But maybe by the end of tonight, we'll talk about lists, which are another kind of data type, which will make that a lot easier. Yay, Boolean logic, yay! Okay, so, yeah, playing's very simple with the pet. You know, just simply ask, if they're happy to play or not. Then if, if they're hungry, then they can't play either. And plus, they lose a lot of happiness if you try and play with them and they're too hungry. So if they're not too sad, and they're not, too hungry, then you can choose what you want to throw, etc. Then they retrieve it. It's pretty basic type stuff. We should probably move on to some new stuff. I kind of want to review what happened last time, though, for the new guys that might be watching on YouTube or in the chat. All right, so we have these other activities, right? Cleaning. It just turns the poop on floor value back to false. Remember, if the poop on floor value starts as false, and if they poop on the floor, then it gets flipped to being true. Right? So we're flipping it back to false here. We clean the floor up. There's no more poop on the floor. That's now false. We assigned the value false to the name poop on floor. We assigned, the value to the name, or vice versa, the name to the value. Okay. If you try and clean, there is no poop on the floor. It says here, if poop on floor, when you try to clean, well, then clean it. But if you type in the word clean, and there was no poop on the floor, then the else block gets triggered, right? It says there's nothing to clean. Your room's already clean, man. There's no poop there. If we punched in the term dagger, it's a cheat code. Our friend TF Dagger requested last time we put in a cheat code for the game. And then, so if you type in, feed, it feeds. If it plays, then it plays. If you want to clean, then it cleans. Type in dagger. All it says here is a little statement here. Dagger's that dude. How could pet's name not love him? Right? So how could Steve not love him? How could Coolin not love him? Then pet's happiness gets maxed out. Right? It goes to 100 anyway. Then finally, if there was none of the above they typed in, then, just tell them to do some stuff. And then continue. So we learned about break, right? Break will forcibly end your loop. But continue is a similar kind of statement. But instead of breaking out forcibly, it forcibly restarts the loop. It says, ignore the rest of the code in the block, ignore all this code, and go right back to the top of the loop. Right? So instead of going to the very bottom of the loop and then going back to the top, which is typical of a while loop, instead it says just go right here, continue, and go right back to the top. It's kind of like that go-to that Kaus has mentioned earlier, right, in basic. It just says here, go back to the top of the loop. So we go back up here and ask again, what do you want to do with your pet? Right? So normally the while loop will go all the way to the bottom and then go back to the top, then go all the way to the bottom, etc. The bottom of the block to where it stops indenting, then go back to the top where it starts indenting, and then do it that way. But if you break out, it'll just stop it right there and go to the very end of the loop and just exit it. And if you continue, it goes to the very top of the loop again, right where you said continue, right? Right here, for instance, with the rocks. If you feed the pet rocks, it prints off "Don't do that, you meanie," and then continues. It goes right back to the top, and that's what you want to do. It doesn't actually, calculate the new happiness for the food. It doesn't, say that Steve eats the rocks. None of that happens because it just continues right here. It says go back to the top. Right. So we can do that right now. Let's run our code. I want to call this K. Reich Jr. I want to feed K. Reich some pie. Okay, he likes pie a lot. I want to feed K. Reich rocks. It says, don't do that, you meanie. And then it asks again, do you want to feed or play with K. Reich? So it doesn't actually do this stuff down here, right? It doesn't actually say that he eats the rocks. It doesn't give me a message based on how happy he is. It just goes back to the top. Continue. Don't do that, you meanie. Print a blank line. then continue. Go back to the very top of the loop and ask again, do you want to feed or play with Kreg? That's how our code works now. Here's our goal for today. Our goal for today is to take this program we wrote and make it a bit easier to understand. Right? I kind of explained it to you guys how it works. We have this big logic tree where it asks what you want to do with the pet, and then inside of this big code block, it does that thing. Right? If you want to feed the pet, then here's all the feeding code. Right? If you want to play with the pet, then here's all the playing code. If you want to quit, then here's the quitting code. Right? All this code, it's all broken up by what you want to do with the pet. Right? But what's kind of frustrating is that if you're scrolling past pretty quickly, it's hard to understand that. It doesn't really kind of convey that to you, that it's a big tree of what you're choosing to do and then what's happening. Right? It appears to just be a bunch of lines of code. So we're going to use functions today to break this into smaller bite-sized chunks that are much easier to understand. You feed Name rocks and Name loses all his or her teeth. No! That's too mean. I'm saying super meany. That's too mean. So let's talk about functions one more time, guys. We know about two functions in Python, right? We know about two built-in functions. We never made one ourselves. The two built-ins that we know about are input, which takes an argument of the prompt. You want to input them. You want to get the input from. There's the prompt. Then it returns whatever the user typed in. You can save to a value. And we know about print. Right? Print is the function that puts text on the screen. You can see us using it right here. It says print, don't do that, you meanie. So the argument of print, right? The function is this, right? The function is print. That's the name of the function, right? To call it, you put in some parentheses. Now that function's going to run. And if you want to feed it some data to do its job better, you call that an argument. You put that between the two parentheses there. Don't do that, you meanie. So that means here, print this text onto the screen. That's the argument, right? The print takes. What do you want to show on the screen? And if you don't give it an argument, it prints off a blank line. Right? So here we have, the text we're printing, followed by a blank line being printed. Right? We call the print function twice. Okay? It doesn't return any. I can't say here, returned value equals. So with input we can, right? Here's input. Input returns a value, which is what you typed in. Right? We can save that to a value name, like pet's food. Right? What do you want to feed the pet? Is saved as pet's food. So it spits a value back out. It takes an argument and spits a value back out, which is the return value. But print does not return a value. It technically does. It's called none. That's another data type in Python, which just means nothing. Right? So we don't want to save this value. So all we can do is print it like this. That's why you see print being called like so, right? Very simple line. And input being called like so. Because input returns a value. You want to save that value most of the time. Right? The whole point of calling input is to get a value back. Right? So input returns a value, we can save it like that. Let's make our own function though, huh? Let's make a function, let's see here. We'll do it up here at the very top. DEF means define a new function. We'll give it a name. We'll call this, scold player. Right, scold player. Then you give it some parentheses there, like this. Have some arguments in the middle. We don't have any arguments there for now. Then we're going to put a colon there, just like any other kind of code block. So a function definition is a code block. Right? Here's our definition of that code block. Ends in a colon. Next line's indented, right? Just like with while or if or else or elif. Right? Next line's indented. We're going to say here, print, don't do that, you meanie. Okay, that's the entire function. It's a one-line function. Right? So now down here, we can call, let's put a blank line there too. That's a two-line function. Okay? So now we can call that function down here. We defined it above, right? We already defined it. We can say scold player. Okay. There you go. So now we go here to our code, let's run it. And we can say pet's name is going to be Carrick Jr. again. I want to feed Kenny some rocks. It says, don't do that, you meanie, right? So it called scold player. It's kind of like a go-to, like Kaus has mentioned earlier. It called this function that we wrote, scold player. We wrote the function up here. Here it is, scold player. All it does is print off two messages, right? Prints off, don't do that, you meanie, then a blank line. That's all it does. Cool. Awesome. It's our first function, guys. So basically we're saying here, run this code up here in our function definition. Then when you're done running it, then carry on. Right? So we'll continue in this case. Now, here's something interesting about this already. As you can see, some lines in our code tree right now are very deeply indented. Right? What's the deepest one? These ones here. These lines are indented by 20 spaces. Right? That's crazy. And what's interesting here is that scold player. Right? I'm gonna say here, don't print rocks. Don't print. Don't do that, you meanie. Print a blank line like I did before. This is indented by what, like 12 spaces? Yeah, 12 spaces here. It's 3 indentation levels. It's a code block inside of a code block inside of a code block. Right? We have 12 spaces there. But if I instead call scold player, now we have this one line indented by 12 spaces, but the actual function itself is indented by only 4. Right? Because this code is inside of the function definition code block, which requires a 4-space indent. But we can call it anywhere. Or we can call it all the way in here. So defining functions and breaking up your code that way is an awesome way to minimize how deeply you're indenting your code, because it can be kind of frustrating when you have, you're all the way over here and you're like typing and it's going off the screen. That's a pain in the ass, right? So it's one way to help us out in terms of keeping code less indented. Furthermore, when you have a function definition, you can name it something cool, like scold player. So before, if I had, let's say, a bunch of lines scolding the player right here, you scroll past quickly, you might not realize what it's doing. Right? It can be a lot of code sometimes. If you name your function scold player, then we know what's happening right here. We're scolding the player. It's very clear to us. It says right there, scold player. Right? If pet food is rocks, then scold player. Here's something else that's kind of cool about function definitions, right? We can scold the player in other ways and just reuse this line of code. Right? Let's do that right now, in fact. Why don't we go down here to play, and it says here, pet's name's too hungry to play. Right? We can say here, don't do that, you meanie. Scold player. Right? Save. Let's run this code now. Run the module. Pet's name is going to be GeoTrack. What's up, GeoTrack? Welcome aboard. And we're going to play with GeoTrack. I think he's too hungry, right? It says here, he's too hungry to play. Don't do that, you meanie. Right? Don't ask him to play if he's too hungry. So even though we only typed in this this string once, this print statement, we can use it any number of times we want. Right? So we can kind of save lines of code that way. If this were like a 10-line function, we would save many lines by calling it repeatedly. Right? It says here, why do you have random prints all over your code? It's so we're gonna read it a little bit better, right? Excuse me, I'm trying to break up the text for the player a little bit on their side. You can also do that by appending a new line character to the end. But that's something that's a little more advanced for our beginners here. Yeah, I know exactly GeoTrack. Yeah, we're at the beginner tutorial. I don't want to talk about escape characters yet. I think for now it makes more sense just print off a blank line with the print statement. So what GeoTrack is saying is that if you end a string with this \n, it will automatically put a new line at the end of your string. Right? In our case, we're just using print to do that instead. Just print whenever we need a blank line, just print. Welcome aboard, homeboy. Okay. So we have this new function, right? Our very first function ever, scold player. Okay, it's a very simple function. What's cool about this function is that it does a thing, but it doesn't do anything interesting because it does not take an argument at all. Right? It just does this all the time. But what we can do is we can give it an argument, right? Kind of like how print takes an argument for what you want to print on screen. Right? We can do that. We can show that right here. Right? Print takes an argument of what you want to show on the screen, and input takes an argument of what you want to prompt the user with. Right? What do you want to feed so-and-so? That's your prompt. But our own functions we make ourselves can also take arguments and use those arguments in some way. Why don't we go up here and we're going to say here, scold player, but we have to have the pet's name. Right? So saying here, whatever data is fed into our function as an argument is getting the name pet's name. Right? Then we can say here, don't do that to plus pet's name plus you meanie. Right? So now we have an argument that we're using. Right? And we're going to use that argument somewhere in our code, in our function. Let's go do that. Let's go down here to scold player for feeding them rocks. I'm going to add in the pet's name. So now that function knows what the pet's name is. Cow says, oh shit, I didn't know that. Or did I? Dun dun dun. Maybe. Possibly. Okay, so let's go down here to, we also use this, so I'm going to delete from here, right? The scold player, I don't need that down here. Just want to demonstrate that, how that works. Okay, so let's run our code again. We're going to call this guy geotrack. We're going to feed him rocks this time, though. And that says, don't do that to geotrack, you meanie. So before it just said, don't do that, you meanie. But now it knows the pet's name because we fed it the pet's name as an argument. Right? So here's our code for scolding the player for feeding him rocks. Right here. And we fed it the pet's name as an argument. Right? When you call a function, you need parentheses. And to feed it an argument, you put that argument between the parentheses. Right? So now in our function definition up here, we see that we take an argument, pet's name. Before it was like this, right? Before it didn't take any arguments. But now it does. And now we can use that argument down here in our code. Right? We saved it from here, the first slot in our, our arguments list. Then we used it down here. Don't do that to geotrack, you meanie. Alright, so that's all well and good and everything. But it doesn't answer how input, for instance, gives us data back. Right? So we know about how to use arguments. Right? But we don't know how to give data back. Well, you do that using a return statement at the end of your function. So return will end your function and it'll give you back some data. Whoop-de-doo. Did you want to call out that pet's name in your function is different from the pet's name in your main code? Not right now, Kenny. I considered it, trust me. For now, I'm going to leave that as it is. So we're returning this string, whoop-de-doo. Right. Yeah, Kenny is a guy that I've helped learn some programming lately. And he's really advanced very quickly. I've really been very impressed with his progress. He is way, way ahead of us here and as total beginners. What Kenny's pointing out is that you can reuse variable names in your code, and depending on where you reuse them, it's not going to always refer to the same thing. Right? So the name pet's food in our main code refers to what we saved right here. Here we saved pet's name, right? So in our main code, it refers to this value. However, in our function up here, we're saving pet's name. This is a whole different pet's name. This is the argument. We could actually call this whatever we want. We call this, pet's, nickname or pet's title, right? Pet's moniker. Doesn't really matter, right? So here we're saying, we say here, use pet's moniker in this spot. We're saying use the first argument, right? The argument that was called pet's moniker. Use that, right? And we can feed in pet's name down here, right? Here in our scolding code. This here, scold player pet's name, right? So we're feeding it this pet's name value, which we saved right here. This was the name, Carrick Jr. or Steve or whatever you want to save the name as, whatever your pet's name is. It says here, feed this function that value as an argument. Then up here in the actual function code, it's saying here, whatever we got fed as our argument, call it pet's moniker. Right? So when it was fed to us, it was pet's name. But we're calling it in our function pet's moniker. Right? Whatever is our first argument here, call that pet's moniker and use that right here. Right? That's really all there is to that. It's like a little bit complicated. You guys get the hang of it as you test it out there. There's a walking, talking Stephen Hawking. Walking, talking. Stephen Hawking, one of the coolest names on Twitch. Hopefully you had a pretty good week so far, I hope. Was up to average? I'm sorry, I think I missed you coming by. So we're returning a value, right? Whoop-de-doo. Let's go down here and to our scolding code. Now our scolding code returns a value, right? Here's the scolding right here. Now we can say here, returned value equals whatever is returned by scold player. Then we're going to print it off. Print returned value. I know, Walken, I'm sorry. I do talk very fast. As a host, it's not always ideal. Let's run our code. Let's call our pet walking, talking, Stephen Hawking. I misspelled that. It's okay. I want to feed him rocks. This here, don't do that to walk and talk and Stephen Hawking, you meanie. Whoop-de-doo. It says, so whoop-de-doo. I did that right here, right? It says here, returned value equals whatever's returned by scold player. Then print that off. Well, we know that it returns whoop-de-doo, right? It always returns whoop-de-doo, no matter what. That's why I printed that off. So this function can give us back a value. It can give us back a value, right? So here we got that value back as returned value. We saved that name. We printed it off. It says a whoop-de-doo. What's up, a Putin roaster? Are you secretly an AI? Perhaps. If I am, I'm unaware of it. I was probably programmed to be unaware of it. I really couldn't tell you either way. Okay, so we have this, welcome aboard, by the way, Putin roaster. Scold player is our first ever function. It's a very, very simple function. It doesn't really do a whole lot. But here's what we're going to do, guys. We have this big logic tree of, you know, if you want to feed your pet, do all this shit, right? And if you want to play with your pet, then do all this shit, right? And if you want to quit the game, then do all this, etc., right? That's what we got. So, instead of having it be this big tower of code, why don't we break this up to make it a bit easier to read and just say something along the lines of, I'm going to save this. I want to just get rid of this and just say here, if you want to feed your pet, then feed pet. That's way easier to read, right? And what's more, if we go up here and define a feed pet function, right? Define feed pet, then we can actually get this code here and make it less indented, right? So it's a win-win for everybody. And furthermore, instead of this being like a mysterious if block, right? You're saying, well, if they want to play with their, if they want to feed their pet, then run this code. Now, you know, if we come back to this code next week, or somebody else wants to use our code, then we can know right away what this code is for. It says right there, feed pet. Right? So that's all these advantages of using functions. It makes your code easier to break down. It makes it easier to read. It makes it easier to organize. Right? It's not going to be that simple though, guys. I'm going to show you guys why we have some problems here. But anyway, so we have this, we've broke up our code now. It's less indented now, a little bit easier to read. We know what it does inside this function here, feed pet. Couldn't be more clear what it does. It feeds the pet. Right? And plus down here, it makes our logic tree easier to read. It says here, if we want to feed the pet, right? If pet activity equals feed pet is equivalent to feed pet, right? Then just feed them. Just feed them, right? Do the same thing with play, right? Get rid of this code here. Cut it out. Then just say here, play with pet, right? Easy. I'm going to put the whole thing there. Easy. Now you know what's happening there very easily. Let's go up here, make a new function. Def play with pet. Right? Paste that in there. And once again, we have the luxury of removing some indentation now. Right? Make it a little bit easier to read, not quite as far to the right. Not as much text scrolling off the screen, because we're typing very long lines here. I think I actually reduced this. It's probably an easier way to reduce all these lines by 4 spaces. But for now, we're just going to use the old-fashioned way. With the arrow keys. Like a big dum-dum. Like a dum-dum. Okay. There you go. So, now we have this code block here, and we know for sure that it's playing with the pet, right? It says right there. Define a function, play with pet. Here's what it does. Plays with the pet. Couldn't be simpler. Right? For now. There, now our entire code tree here is way easier to read, the main code loop, right? So we get the input, what you want to do from the player. If they want to feed the pet, then feed them. If you want to play with the pet, well then play with them. If you want to quit, then print off, they're going to bed, and then you break out of the loop. Right? Game over. If you want to clean up after them, then we say here, well if they poop on the floor, well then clean up after them. Otherwise, nothing to clean. If you want a dagger, then here's our cheat code. right? Gives you max happiness, more or less. Then otherwise, print out, you have to print out an error message, please either feed or play with so-and-so, right? Finally, at the end of our loop, we say, if they're hungry, then, reduce their happiness a little bit. If they poop on the floor, reduce their happiness a little bit. And if their happiness is too low, then it's game over. They bite you. Now, you just build a Schrodinger's cat logic with that AI statement, huh? The paradoxes. Mad paradoxes. All right, so here's our problem, though, guys. So our code is already way fucking cleaner. The problem is it don't run. The code doesn't run. It's cleaner, which is great. Easier to read. Awesome. It does not run. Let's actually try and run and see what happens. Run module. Continue not properly in loop. What do you mean not properly in loop? Let's see here. Syntax error. Right here, huh? In feed pet. What do you mean it's not in a loop? It says here, pet's food equals, what do you want to feed your pet's name? So whatever they type in, okay. All right. If it's their favorite food or their second favorite food, then give them happiness. All right. Otherwise, take away their happiness. If it's rocks, scold the player. Oh, continue. Well, it's not inside of a while loop anymore. We know that continue will go back to the top of the enclosing loop, right? And break will break out of the enclosing loop, right? But there is no enclosing loop. It's inside of a function now. There's no while or anything. There's no kind of loop that we know of. Okay, well, that sucks. What can we do? How can we fix this code now? If they feed the pet rocks, we don't want to have them eat the rocks, as shown here. We want to end, right? Well, we learned that we can end our function by returning. Okay. That's halfway solves our problem. Why don't we return a value that tells our main code loop to continue? I'm going to return true. Okay. Watch this, guys. So it returns true now if they fed the pet rocks. Right? Fed it rocks, then returns true. Okay. And if it hits the bottom of the code block, the bottom of our function, without breaking out, let's return false. Here's the bottom, right? Return false. Now we can go down here to our feeding our pet code in our main loop here, and say pet ate rocks, or pet fed pet rocks, right? Fed pet rocks equals what's returned by feed pet, right? So if he fed the pet some rocks, or tried to, we return true. Otherwise, if the code executes completely, we return false. Right? So if we return true, which only happens if we fed the pet rocks, then we can say, if fed pet rocks, then we can continue. Go back to the top. Think of the file of Alfred Montbank, or Montbank. We do programming here every Friday as a tutorial for beginner programmers. If you have any questions, let me know. We're really more geared toward like beginner type stuff here. This is episode 3 of our series, guys. Episode 3 is kind of like middle in terms of middling complexity. We're learning a little more complex stuff here than for episodes 1 and 2. Okay, so if we fed the pet rocks, then continue inside of our loop. Well, that kind of solves our problem, right? Also, because a feed pet returns a Boolean true or false, we can just call this too. We can just say if feed pet. Like that. Right? It's the same thing. So feed pet returns true or false. So if feed pet, we call feed pet, whatever it returns, if that's true or false, then continue. That saves a little bit of space that way. Okay. Well, that solves our problem, surely. Right? Let's run this code now. What's your pet's name? No syntax errors. Okay, I'm going to call him a cow says. You want to feed or play with the cow says? I want to feed him. Okay, so it says here, what do you want to feed a cow says? So we're running this function now. We're inside of the feed pet function. Hey, we're making progress, right? Cool beans. Let's feed him some, he hates oranges, right? I'm going to feed him a bunch of oranges. Where is that defined at? Down here, right? Yeah, feed him an orange. He hates oranges. I'm going to feed him an orange. Uh-oh. It says here, local variable. We have an error here. Our program crashed. We get an error back. There's a Python feature that makes it a little bit easier to figure out what went wrong in your program. It says here, here's our file. Okay. On line 83, we tried to feed pet. Here's where our error happens. It's on line 83. That's where the error happened. Okay, let's see here. Where is that? Line 83. Right here, line 83, right? If feed pet. Oh, then it's more complex than that, right? It says here, okay, well, also in that same file, on line 13, so this line's where the actual error happened, but on line 13 is, it's essentially the same line, right? It's kind of complex to understand, but here's our function call. So line 83 is our function call, right? This is where the error happened. But the function call itself points to a bigger block of code, right? Function calls point to other code. So it happened on this line, but actually happened on line 13, it says, inside that function. Okay, line 13 right here. It says here, local variable pet's happiness referenced before assignment. What does that mean? Pet's happiness referenced before assignment. Oh, it's because pet's happiness is defined down here for the first time. Exactly, to average. Average says you called a variable before you told the computer what it did, what it does. Yeah, so up here we're saying, I want to use this value, pet's happiness, right? I want to lower it by 40. And they're like, what's pet's happiness? What do you mean lower pet's happiness by 40? Well, I don't know what pet's happiness is. Right? That's because we defined it down here, right? And we're using it up here. Okay. Well, then I should probably just define it up there, right? See if that works. Cut that out, paste it up at the very top. Put it for our feed code. How about that? There you go. Now it's before the function. Is that going to work, you guys think? Let's find out. I hope you're enjoying it at 2 Average Gaming. Python is awesome. Sounds like you're having a little bit of trouble though, right? You run to the crash screen a lot. It's totally not unusual. Even me, as a guy who's been programming Python for many years, I still get that crash all the time. That's part of making a program work is having it fail. We're going to call this pet name 2 Average Gaming. I want to feed him orange. No. It's still referenced before assignment. Pet's happiness referenced before assignment. I just find it right here, though. Pet's happiness. Why is it giving me that error message? Well, because inside of this function, it does not know what that is. Right? We have to define that as an argument for it to know what it is, essentially. Right, kind of. To be honest, I'm not sure why that's not working. I think that should work. Pet's happiness, defined right there. It's okay, whatever. So we have to define it as an argument. You should be able to call globals. That's what I'm thinking, guys. It shouldn't be a global. I think it should be a global. Anyway, so we're going to move it back to where it was. I wasn't sure if that would work or not, to be honest. But it doesn't work, so I know how to fix it. Let's go down here, put that back where it belongs. Okay, so basically, we have to supply this value as an argument. Right? So here we have pet, feed pet. So take an argument now, pet's happiness. Okay, cool. We'll call it pet happy level, right? So like Kenny said, to differentiate it from the other value, pet's happiness. In the function. Okay. So I'm surprised by that. You can't use constants inside functions. Pretty sure you can, right? How is that different? Anyway, so we have this argument now, right? Pet's happy level. Right. We can use that here now, right? Pet's happy level. Pet's happy level. Pet's happy level. Right. All this stuff. Okay. We're going to have another problem here, guys. I'm going to talk about that in a second, too. All right, pet's name, pet's happiness. We have pet's happy level instead inside of our function, right? That's our argument name. Pet's happy level. Okay, pet's happy level. Okay. There you go. So now we've placed all the occurrences of pet's happiness inside of our function with pet's happy level, which is an argument that it takes. Right? So functions take data in, and they can return data out. Right? So we're taking in a argument, pet's happy level, and we're using it throughout our code. Right? That's awesome. Let's go down here to where we actually call our function. Let's just run it first, see what happens. Run our code. What's your pet's name? I'm going to call him K-Reich again. I want to feed K-Reich. Uh-oh. Crashed again. What line here? Okay, here's our file name. Okay, that's what we're editing right now. Line 84, if feed pet. Okay, line 84. It says here, a type error. Feed pet missing one required positional argument. Pet's happy level. Why would that happen? Here's our definition for our function, right? So feed pet requires one argument, pet's happy level. Oh, right, I didn't define that yet, right? Let's go down here to line 84 as it told us. Right here, feed. We did not give it an argument. It needs an argument now, right? It needs the pet's happy level. So I'm going to give that the pet's happiness as that argument, right? So feed pet, pet's happiness, right? So we're going to give it a value to play with, right? So when you make a function, you can feed it data as arguments, right? So it needs this data to work right. So I'm going to give it this data now. Okay, awesome. That should solve that problem, right? Code should run fine now, right, guys? This is the real Python experience, guys. In Python, sometimes you don't know what the hell the problem is, and you crash your code over and over again until it works right. I think it's going to work now, but not in a way that we expect. Actually, it won't work, because we still referring to the hunger level before we're defining it. Anyway, K-Reich Jr. I want to feed K-Reich. I want to give him an orange. Oh, well, it crashed again. It says here, on line 84 is where it crashed. Well, that's our function call. Right, here's line 84. You can see that right there in idle, lower right. This is actually, it happened on line 34. That's a function call, right? So basically it happened inside the function. Line 34 is where it actually happened. Okay, let's go up here to line 34. Where's that at? Right here, line 34. It says here, local variable pet's hunger reference before assignment. So same problem as before, right? It doesn't know what pet's hunger is. It cannot subtract 20 from pet's hunger without knowing what pet's hunger is. Okay, let's give it another argument then. First time using two arguments. We need a comma, pet's hunger level. Okay. Cool. So now down here, let's change this value to pet's hunger level minus equals 20. So we have an argument now, right? We have an argument called pet's hunger level and pet's happy level. And we can use those arguments inside of our function to do its job right. All right, down here as well. So it's pet's hunger level. There you go. Run this code now. Run it. What's your pet's name? Kenny. Feed him. Oh, he needs an argument. Pet's hunger level. Fuck, forgot to do that, right? Let's go down here to our while block. If feed pet, pet's happiness, and pet's hunger as the second argument now we need, right? There you go. So now it has two arguments that can use to do its job correctly. Let's run this. Okay, pet's name, Kenny. Feed it an orange. Okay. I'm sorry, I have to feed him. Feed him an orange. Okay, so Kenny eats the orange. Kenny seems mad depressed. Kenny seems kind of hungry. Mad depressed. Okay. Well, then if I feed him anything else, it should end the game immediately, right? If I feed him an orange, it should definitely end. Let's feed Kenny an orange. Well, oh, wait, what? Why didn't it end the game? He started the game at 50 happiness, right? I fed him an orange, which minus 40 happiness. Then I did it again. And he still didn't bite me. Same kind of code style as an Unreal Engine, because if so, that'd be fat. I just downloaded it today. Kind of. As long as you learn the basics of programming, right, about how lines work, how instructions work, yeah, that can carry over to Unreal for sure. So I reduced his happiness twice by 40. He didn't bite me. What's going on here? Well, I'll tell you what's going on here, guys. What happens inside of a function stays inside of a function, guys. It's kind of like Las Vegas. Right? Here we're reducing the pet's happy level, but when that function ends, pet's happy level goes bye-bye. Outside of the function, we have pet's happiness, right? Pet's happiness, and that is never being changed. Right? We fed in the pet's happiness right there as an argument, and that argument is being copied, right, to this new name, pet's happy level. And here we are changing the pet's happy level, sure. But that is not changing pet's happiness outside of the function. Right? That is not changing anything outside of the function. It's just changing inside of the function. Right? So to get new data out of the function, we have to return that data out. Exactly, Lobo, right? It's like Las Vegas. What happens in the function stays in the function unless you return it out. To get data in, you have to give it as an argument. To get new data out, you have to return that data outward. You can't just change it. Now, that's not going to be true forever. As we learn more about objects in probably the 5th episode, the one after next week's episode, we're going to learn about how it's not always true. But for now, as a hard rule, if you change something inside of a function, it doesn't change outside of the function. Right? You have to actually return that new data outward to get it out. Except for herpes, huh? That shit come back with you. That's true. Talk about Las Vegas. So, we're changing something. We're changing the pet's happy level. We're changing the pet's hunger level. And we are changing this poop on floor value. Right? So, we are going to need to return more data outward than just this value of if they fed the pet rocks or not. Right? This is where things get a little more complicated, right? It's a little bit frustrating. So we have this neat little function we have. It takes in 2 arguments, pet's happy level and pet's hunger level. And now it needs to spit a whole bunch of data outward at us. That's being changed afterward. Okay, well, what's being changed here? Well, we're returning... we need to return out whether or not they fed the pet rocks. Let's see here. We need to change if pet's hunger. Thank you, Bruce Tim. Yeah, thank you. He's saying I have this value here, pet's hunger still, which doesn't mean anything. Right? That value doesn't mean anything inside of our function. We have to change that to pet's hunger level. I don't know why I didn't crash our program before, to be honest. Hang on. Let's figure that out first. Diversion, guys. They should have crashed our program right here. What's going on? I'm not going to worry about that for now. We're going to talk about that later on. I'll figure out why that didn't crash. Basically, what's happening here, I think it's a problem with scoping. It's a more advanced topic than I'm willing to talk about right now for you beginners. Anyway, let's change this name to pet's hunger level, for sure. And let's return some more data out of here, right? So it returns false right now. Let's also return the new pet's happy level, right? And the pet's hunger level, and the poop on floor value. Right? It returns a lot of stuff now. See these commas here? It's going to all get spit out now. We're going to learn about a new data type here. Okay. So, let's look at what happens now. So let's go into our function call here. It returns a lot more data now, right? Here's what we're calling if feed pet, right? When we say here, we'll say returned values equals feed pet. Oh, board Bruce Tim, by the way. Pleasure having you here. Right. We say here returned values equals feed pet. When you give 2 arguments, right? Pet's happiness, pet's hunger. So we have this returned values now. Well, that's weird. Typically, so far, we've only looked at data types that contain 1 piece of data. Right? We have pet's values. How am I going to use that? Like this. Watch. I'm going to say here that, fed pet rocks equals returned values 0. Uh-oh. Here we go, guys. It's getting complicated now. I'm going to say here the new value for pet's hunger, or pet's happiness, equals returned values 1, pet's hunger is being reassigned to the value of returned values 2, and poop on floor is being going to be set as returned values 3. Okay. Awesome. I'm going to feed. I should feed in some more data, right? I'm feeding this poop on floor value as well. That's another argument. So we have 3 arguments now and a whole bunch of return values now. Okay. Let's go up here. Add in a new argument here for you know, poop Boolean. Right. We're going to say here, you know, poop Boolean is going to be changed to being true if there's poop now. Okay. Return poop Boolean. And up here as well, see we have this this code where if they feed them rocks, it returns true. We have to change this to return true, pet's happy level, pet's hunger level, and poop Boolean. I'm going to start messing with Unreal with little to no understanding of the program and stream it next month. Wish Moo luck. Akao says that's going to be one hell of a challenge. I wish you luck for sure. It's going to be very challenging. But you got to jump into the deep end sometimes. Okay, so we're turning all this data out. Let's see if this fixes our code. I might have put a typo in there somewhere, knowing me. We're going to call this guy Steve again. I want to feed Steve. I want to feed him an orange. Okay, well, he killed me. That works. Let me try and feed him some French fries. Okay, so, oh, I'm sorry, I did feed French fries. Okay, he seems in high spirits. I want to feed him French fries. He seems ecstatic, so it's working now. Right, it's working. It's saving that value, and here's why it's saving it, guys. So when we feed him French fries, right, let's go over here to our feed pet code. Right, here's all of our feed pet code. Right, it takes in 3 arguments that we have to know to get our job done correctly. It needs to have the pet's current happy level, the pet's current hunger level, and the current poop Boolean. If there's poop on the floor or not already. Right, knowing these 3 things, it can run the code where we feed our pet. Right, and when the function ends, whether it be from feeding the pet rocks or from feeding it any other kind of food, it returns 4 values. It returns whether or not there's poop on the, whether or not you fed the pet rocks. Right? It returns the pet's current happy level at the end of the function. So if it changed, now we're going to see that change. It returns the pet's hunger level by the end of the function, and it returns the poop Boolean by the end of the function. Right? All that stuff. In fact, I think I'm going to simplify the code by getting rid of the poop Boolean. It's called feed pet, right? I'm going to get rid of the pooping part. Right here. I'm going to cut this code and paste it down here in our while loop. Make it a bit more clear what's happening. Right? Here's our feeding code. I'm going to have this poop part happen after we feed them. There we go. Vanko, did you put poop level in yet? I stepped away for a moment. Oh yeah, we have a poop on the floor Boolean. It's not really a level. Right? It's just a true or false if there's poop on the floor or not. Okay, so we can get rid of this now. So our function returns 3 values. Right? It returns whether or not you fed the pet rocks, and it returns the new values for the happiness level and the hunger level. Right? So it happens if you feed the pet rocks, it returns right away and says true. You tried to feed the pet rocks. Right? Here's the current happiness level, here's the current hunger level. And if it survives the entire program, it says false. You did not feed the pet rocks. And here's the current happiness level, and here's the current hunger level. So it always returns 3 values. Right? Previously we talked about you know, returning 1 value at a time and how that works. We have a new kind of value here, though, guys. Right here. This returned values data is broken up into 3 parts. And here we have the syntax or the grammar in Python for getting those 3 parts. Right? Returned values 0, returned values 1, and returned values 2. We're talking about a tuple, guys. A new kind of data. Right? So far we know about strings in Python. Text, in other words. We know about numbers in Python. Integers in this case. We know about Boolean values, which are, true or false. We know about functions, which are themselves data, right? And you can call that data like this. But print itself is a data type, right? It's a function. A callable, it's called in Python. It's a function. And now we know about tuples, right? T-U-P-L-E-S, like something like this. You're going to say here, my first tuple equals true, pet's happiness, and pet's hunger. That's what it looks like. That's a tuple there. So a tuple is a multi-part piece of data, right? And each of those parts of it can be another kind of data, including a tuple. I actually say here, we have a tuple in the middle if we wanted to. Right? And it has, poop on floor, and, pet's hunger. It doesn't really matter, right? Just an example here. So we have a tuple here, right? It contains a Boolean in the first slot, a tuple in the second slot, and pet's hunger in the third slot, which is a integer. Right. So tuple, the name comes from like triple, quadruple, quintuple, etc., etc. That tuple just means it's a multi-part piece of data. Right. It's a data that has multiple parts in it, and so we're returning that right here. In fact, this return statement here could also be written like this. It just so happens that with the return statement, the parentheses are optional. Right? But it's the same thing. We're returning a tuple out of the situation. Right? So anytime you have like commas like that, you're getting a multi-part piece of data back. In this case, a tuple. Okay, so now we have this tuple coming back, and how do we access the individual parts of the tuple? Right? Well, you do it using what's called an index. Right? I'm going to show you guys that real quick. We have this tuple now, right, getting returned back. And we are accessing the data using this index number. So when you have a tuple or any multi-part piece of data, right, there are other ones we're going to learn later on, you can actually access the data from its individual pieces using these square brackets at the end. Kind of like a function call, right? It's kind of like a function call. Instead of having parentheses, you have square brackets. And then you give it a number. That number represents the slot in the tuple you're accessing. And in Python and 99% of other languages that are programming languages, for some reason it was decided a long time ago that the first slot in a multi-part piece of data is the 0th slot. It's not the number 1 slot, it's the 0th slot. A little bit unusual at first, you'll get used to it, and again, that's true of almost every single language out there, so just keep that in mind. So here we have returned values 0 is the fed pet rocks value. If you look up here, you can see that's true, right? The 0th slot of our tuple is false. Right, so we did not feed the pet rocks. Or up here it's true, right? We did feed the pet rocks. And then the first slot, this is after the 0th slot, is the pet's happiness level. You can see that right up here. And the third, or the secondest, the number 2 index, we'll say, index 2 is the pet's hunger, right? So we can word it a whole bunch of different ways. It doesn't matter how you word it. This could be the first slot at index 0. This could be the second slot at index 1. This is the third slot at index 2, right? That's how you read tuples. Another way, another alternative way, if you want to talk about syntactic sugar, is you can say this, right? You could say fed pet rocks, pet's happiness, and pet's hunger equals returned values. I believe that'll work too. So that says I'm giving you a tuple of names to match to your tuple of values. Right? I think that'll work. I hardly ever use that syntactic sugar. Let's see here. Pet's name, Steve. I want to feed Steve. Oh. Oh yeah, I've still given that poop on floor. I don't need poop on floor anymore. Yeah, I think that's how that works, Kenny. I hardly ever use that kind of notation. But it should work. If I run this code now, I want to name the pet Kenny. I want to feed him an orange. Pet's hunger level not defined. That you call it pet hunger level, perhaps? Oh, I'm sorry, it's down here. I'm sorry, I forgot to change the name of this if block here. We have to call this pet's hunger now. Because we're outside of that function. Duh. Okay, pet's name's gonna be Steve. I want to feed him an orange. Okay, he killed me, right? So it did save. It saved the pet's hunger. So yeah, so another way to assign tuples, not using indexes, is to just give a bunch of names for each slot. Give it a tuple of names to your tuple of data. Right, that's one way to do it. But let's just go use indexes again, because it's a little more clear. It's somewhat frowned upon in Python to do things that way. So I'm going to say here, fed pet rocks is returned values the index 0. And we're going to say here, pet's happiness is returned values index 1. And pet's hunger is returned values index 2, or the third slot, right? Because the first slot's 0. Okay, so there you go. So now we have this function that takes 2 arguments and returns out 3 values, right, as a tuple. Because return only gives you back 1 value, right, which is a tuple. That tuple itself contains 3 other values, right? Kind of interesting. Okay, so now our feed works again. Awesome. So we have our feed code now very neatly up here, away from the other code in our function, in our program. So what's cool about this is that if you scroll through this part of our code down here, the main while loop of our program, you can see that the way that feed works is very simply by calling a function, feed pet, right? And then it just gets some values back out of it, and it tests if the pet's has to shit or not, and they shit. It's whatever, no big deal. So before this was a huge tower of code down here, and now it's very simple. If you want to feed the pet, we'll feed it, get some values back, and then have it shit if it has to shit. Right? Same with this here. If you want to play with the pet, then run this function. Now, for all the same reasons as before, this function will not run. Right? We have to fix our function here to return some values, to save some values. Right here it says here, if pet's happiness is greater than or equal to 50, it doesn't know what that is. It does not know what that is. Let's change that right here. We're going to give it a argument, pet's happiness. So we talked before about how the same exact variable name can mean different things in different scopes, right? In different areas of your code. So we found out the hard way that, I don't know, I feel kind of uncomfortable talking about this right now. So basically, pet's happiness, right here it's referring to this argument, right? Pet's happiness. Because it doesn't necessarily know the same pet's happiness we're using down here. So now we're saying here, even though it's the same name, it's not referring to the same thing necessarily, right? It's referring to this first argument slot here, okay? So we're saying here, whatever was supplied as the first argument, compare that to 50, right? What's the pet's hunger? It's going to be our second argument slot, right? Compare that to 60. Right? We have to throw an object, okay. Pet's happiness, okay. Pet's hunger goes up if they when they're done with playing with this whatever. Okay, so here's what's happening here, guys. So we're saying here, if the pet is too unhappy to play, print off this stuff down here. Otherwise, play with the pet. Okay, cool beans. And if the pet's hunger is too high to play, we'll print off they're too hungry to play, and their happiness goes down. But if they're not too hungry to play, then play with them. Right? Choose a thrown object, choose your ball or your stick or whatever you want to throw. Then you throw it. Then we compare their happiness to certain numbers and say if they're this happy, they're going to really happily catch the ball. If they're kind of low on happiness, they kind of lazily catch the ball, etc. When they're done playing, their hunger goes up, right? As you play, your hunger goes up. It's very exhausting work. Awesome. That should work now. But first, we have to return the new values out for happiness and hunger. Right? Let's go down here and do that. Say here, return pet's happiness back out. Return out pet's hunger as well. Okay. Let's go down here to the code where it runs at. Right here, play. Feed it some arguments. Pet's happiness and pet's hunger, and get some data out of it. Right? We're going to say here, returned values equals whatever's returned by that. We're going to say here, pet's happiness equals returned values 0. and pet's hunger equals the second slot of this tuple that was returned, right? AKA index 1. There you go. So now we fed data into our function. It played with the data a little bit, changed some things, spat data back out, and we are saving that data that it spat out, right, as these names again. This should work, I believe. Then I'm going to make it a little bit easier for you guys to read it. I'm going to do it for Kenny, too. This is actually a lesson for Kenny. Let's run this. Kenny is still in some ways a noob, as we all are, including me. Let's say here, I'm going to call this pet K-Rex Jr. I want to play with K-Rex Jr. I think I'm not going to be able to, right? He's too hungry. He's too hungry to play with me. Okay, let's feed him. I want to feed K-Rex Jr. He loves French fries and pie. Give him some French fries. Okay, that's all right. Let's feed him some pie. Now he's in high spirits. I'm going to feed him some more pie. Delicious. Why is he not higher than high spirits? Feed pie. There you go. Okay, so let's play with him now. All right. I want to play fetch with a ball. Okay, he retrieves the ball at lightning speed. Okay, so basically, he was happy, like really, really happy. And I threw him the ball. He was very happy to catch it, right? He's got a lot of energy now. There you go. So that's our whole play loop. The play loop worked. All is well. Let's clean up that play loop, guys, for K-Reg's sake, for Kenny's sake. This is something I think he hasn't learned yet. This is a simple trick in Python to make your code more readable. Right? We know that return will end your function. Right? One way to reduce indentation is to consider return as a way to control the program flow. If you guys are total novices, maybe just ignore this part. It's really for Kenny here. Basically, we know the return ends the function, right? So I'm asking these questions in wrong order here. Look how deep this is indented, right? That's mad deep indentation here. We're saying here, if pet's happiness is greater than 50, then they're willing to play. Run this code, right? Let's change the order. Let's say here, if pet's happiness is less than 50, right? So the opposite question, right? Then we can say here, print, well, we have to have the pet's name. But look, it knew what the pet's name was. So there's something going on here with this pet's happiness level. It's all right. I've been kind of worried about this all night. It's about scoping. So Kenny was wrong, right? We're using globals here on accident. I don't know why it didn't work earlier with pet's happiness. Whatever. So we're saying here, print pet's name, you know, plus isn't in the mood to play, right? And then we're going to print a blank line. Then we're going to return pet's happiness and pet's hunger, right? So what we're accomplishing here is we are now minimizing our indentation because at this point we know that pet's happiness is greater than or equal to 50 because if it wasn't, the function would have already ended, right? So now all this code here, we can get rid of the if statement because we know this is true now, right? If we got this far down in our function, we did not return. That means that we know for sure that pet's happiness is greater than or equal to 50. Get rid of this and unindent this. Thank you for the follow, Unskilled Game. If you have any questions, let me know, dude. We do Python tutorials here every Friday. Okay, so we're basically using return as a way to control our logic tree. In fact, it says right here, if a pet's happiness is greater than 60, well then they're too hungry to play, right? Then it says else, play the game. Okay, well how about we just say here, instead of saying else, play the game, just say return pet's happiness and pet's hunger, right? Now we can get rid of this else too, because again, we know if we got this far down to our program, we did not return yet, which means we know that we're at greater than or equal to 50 happiness and less than or equal to 60 hunger. We're transforming into what a cow says. Look how much indentation we just saved by using that that life hack. So we're looking at logic in a different way here inside of a function, basically. Inside of our function, we're not asking the traditional if-else, right? If this, do that. Instead, we're saying, if this is true, we'll then end the function. Okay, well, if we're still going, then if this is true, end the function. And if those weren't true, then keep going with the function. Right? So we saved ourselves a lot of indentation that way. Yo, let's go, Philip. It's gonna be later tonight, dude. It's Minecraft later tonight. I don't know the idea, but I'm awful at thinking in that kind of way, so I appreciate the insight. I only started doing this a couple years ago, so that's why I thought you might find it interesting. It's a new way of looking at logic because you're inside of a function, right? You can just return out. So there you go. So we have a little bit less indentation now. That's awesome. What do you transform into? A cow says. Oh, a slime says. Okay, you're changing your moniker there. Oh, he's into slime form. Okay, so we have this code here. I'm going to supply some more arguments because this function needs to have pet's name to work. All right, let's supply that right here too. Pet's name, and up here as well with feed pet. It has to know the pet's name to work. The pet's name's not going to be changed inside of the function, so we're not going to return it out. Right? We're not going to return it out, but we are going to supply it so it can do its job correctly. It was doing the job correctly before. That's an issue I'm going to talk about more, probably in a later stream, about scoping. That's really more of a higher level topic. Supply it pet's name was the first argument now for both of these, so we can know the pet's name for sure. There you go. It has to do with global variables and scoping. Just a little fun. I switched devices, just so happened to be logged into a different account, huh? I gotcha. Okay, so let's run this code. It should still work. Run module. Pet's name is going to be a slime says. We're going to feed it some pie. Awesome, it's in high spirits, kind of hungry still. Let's feed it some French fries, likes both those things. Okay, now it's ecstatic. Let's play with it. I want to play fetch with a pocket watch. It says here, a slime says retrieves a pocket watch. I throw the pocket watch. A slime says retrieves it with lightning speed. That seems kind of hungry now. Yeah, it's lost a little bit of energy there from catching, right? If you look up here in our playing code, you can see that after it's done doing its play, it gets more hungry. Right there. I'm actually get some more blank lines in here because it's a little bit jumbled up. A little bit make it easier to read this way, right? I mentioned before earlier in the stream, guys, that having blank lines in Python has no effect on the code whatsoever. It just makes it easier for you to read as a programmer. I like to put blank lines sometimes before and after code blocks, such as if. Like that, right? There you go. And we're also doing it, before the return here at the end of the function. You're not a real slime. What? Are you still a cow? Are you calling yourself a slime, says? Okay, so we have this play with pet function, and we have this feed pet function, right? So what we've accomplished today so far is we took a very big monolithic piece of code down here in our main code block, and we broke it up into multiple functions that now we can go up here to the top of our code and read how they both work. Right, let's get rid of the scold player. I don't need this. This is just a little goofy function we wrote to teach us how to write functions, right? Let's go here to scold player and just say, get rid of this code here. And simply say, print, don't do that, you mean. Right. Then print a blank line. Okay, so we have this code up here for feeding the pet. Right? We have this code here for playing with the pet. I should put another blank line. We already do. And then we have this code here. This is where the code, this is where the program actually starts, right? So we talked about code blocks and how code blocks run only under certain circumstances, and they might not always run top to bottom either, right? So we talked about, start of our stream, we talked about while, how while works, right? You define your code block, end the line with a colon, then you indent, right? The entire code block becomes indented. This is our while block. The entire indented code, down to here, right? This is our last line of our while block. Here's the first line outside of the while block, right? Print is outside of that while block. Okay, we learned about how, it's in with if, right? If will only run under a certain condition. This code will not run if this statement is not true. And this code for the else block will not run if this statement is true. Right? So code blocks run conditionally. They don't always run. These lines right here, they are not inside of a code block. Right? They're all the way indented to the far left, right? They're not preceded by a line that ends in a colon like this. So this code will always run top to bottom no matter what. This code's always going to run, right? Any code inside of a code block might not run, right? And it might not always run top to bottom either, kind of like how while true always runs, if it hits the bottom, it goes back to the top again. Right? So that kind of adds interest to your program as these code blocks. They get very creative with these. And likewise, these function definitions up here are code blocks. You know, it starts off with a definition line, ending in a colon. Then all the lines inside of the code block are indented. Right? So here's our entire feed pet function. That's the entire code block, right? Here we see this line is not indented anymore. That's the first line outside of that function. Then all this code is inside the play with pet function. Right? And here's our first line outside of that function. So up here, although we start our program with function definitions, it's kind of traditional to start your program with your function definitions. After your imports, we're going to learn about that quite yet. But typically for our program, we're starting off with the function definitions. This code here is not running, right? Only this line is running, where we define the function. The function is defined, right? This code is not going to be run until we call it. Likewise, down here, our next line that we're going to be running is this function, defining this line, defining this function. Right? So we've run 2 lines so far in this program. We defined this function, and we defined this function. After that, we defined some more data. Because remember, functions are data, guys. So we've defined some data there, some functions. We're defining more data here. Pet's favorite food 1 and 2, French fries and pie. Pet's hated food, orange. And pet's happiness and hunger levels, and the poop on floor Boolean. Right? Then we ask the player, what their pet's name is, print a blank line, then we get into the actual loop of the game. The loop of the game is asking the player what they want to do, and then doing it. Asking again what they want to do, and then doing it over and over again until we forcibly break out of the loop, right? Either by quitting, right here, or by having the pet be too unhappy with us, right down here, at the very end of the loop, right? The very end of our while loop, it says, if the pet's happiness is below 0 or below, then break out of the loop. Game over. Otherwise, go back to the top. Thank you for the follow, Ulrich10. We do programming streams here every Friday, kind of like a tutorial. We do game dev tutorials for newbie programmers. I love programming. I'd love it if you guys loved it too. To me, it's been a really great thing in my life, and if you guys could enjoy it as much as I do, I'd be very happy with that. By all means, ask any questions you might have. If you have questions when I'm not streaming, ask on Discord, Vencabot.com. I can definitely help you out anytime. I have friends as well that might be able to help you. Okay, so now our program, again, it's way easier to read. Right? We can see that we have this, if you want to feed the pet, then run this. If you want to play with the pet, then run this. If you want to quit the game, then run this. If you want to clean up after the pet, run this. If you want to use a cheat code, then do this. Otherwise, if you try to do something that's not listed there, then get an error message. We don't know what you're trying to do there. And then afterward, check to see if the pet's still hungry. If they are, then they get a little bit unhappy. If there's poop on the floor at that point, they get unhappy. And if they're too unhappy, then the pet bites you and the game ends. And then if that's not true, well, that's fine. Go back to the top again and start the game over again. Ask what you want to do with the pet. Right? So at the start of today's stream, we had all this code up here, down here, inside of the while loop, right, for feeding and stuff. And that was a little bit overwhelming, kind of hard to tell what was happening. Now our most complex code is hidden. Right? A lot of programming is what's called abstraction. When you abstract something, you are hiding the complexity to make your code easier to understand for someone who wants to manage their investment in your code. What does that mean? That means that if you are someone who's trying to figure out maybe how the quitting works in your game, you don't give a fuck about how the feeding works or how the playing works, right? So don't make them scroll past all that nonsense, or don't make them get confused about where the quit part is. Right? The quit part is very clearly right here. It says so right there. Right? If we had a million lines of code for feeding and playing, it'd be more difficult to understand what's going on in this big while block. Because we've minimized the amount of complexity in this while block now, we can see very clearly, oh, it's just asking what you want to do. Right? Ask what you want to do, and it does it over and over again. Before, we had to scroll down past several screens of playing code and feeding code to really see that this was one big logic tree, to kind of comparing your entered text against this list of commands. Right? But now that we kind of hid some of that complexity away, it's more clear to understand how this is working. And furthermore, what's cool about it is that if you do want to learn about how feeding works, you can say, well, here's feed. Oh, there's a feed pet function. So now the feeding part is isolated up here, right? So now you also know for a fact that feeding starts here and ends here. There is no more code related to feeding in our game. And again, as a way to manage your investment, that's awesome. If you want to only know how feeding works, it's right there. Right? If you don't give a shit about how playing works or how quitting works or how cleaning works, feed pet is right here in one function for you. That makes your code a lot easier to read. Thanks for the follows, by the way, guys. I'm sorry, I missed a couple follows there. I can't check them right now. I'll check them when the stream's over, though. But thank you. We stream Intro to Python here every Friday as a tutorial for kind of like learning to program your first program ever, which is going to be a game in our case. It's episode 3, guys. Episode 3 is a little bit more complex than episodes 1 and 2. We're learning about functions today and how they work and why you want to use them. Right? There's all kinds of cool reasons to use functions, and this is one of the major ones. It's making your code more manageable, more readable, more abstract. Abstract is good. It means, you know, having that complexity there. Of course, you have to have the complexity to make the program work, right? I mean, it's going to be complex, but can you organize that complexity in a way that makes it easier for you to choose your level of commitment to the program? Right? How much do you want to actually see? Do you want to see it all right now? Or do you want to hide some of it that's not really important to you right now? Right? That's what functions are all about. And again, furthermore, we're going to learn about, you know, packaging in the future, libraries. Those are all ways to further abstract your code so that you can control how much you're seeing at one time. Right? Basically, if you're working on one part of your code, you don't got to know about all of it. Right? You don't have to know about that one part you're working on. Right? That's really the ideal. So Slime said, this is really neat stuff. I took a couple classes in school, and I always like watching vids on YouTube and stuff. Please keep up these kinds of streams, my dude. They've gotten an okay reception so far, Slime says. We're probably going to be doing this for a while longer anyway. Dagger says, do all the work on complexity on the front end, then just call the function with some args later. Exactly, Dagger, exactly. Welcome aboard, Dagger. We were talking about you earlier because of your cheat code in this game, the Dagger cheat. But yeah, so basically, as you become stronger programmers, guys, you're going to find new ways to abstract your code, to say, this part is important to my program, it's just that I don't care about it right now, so why don't I just push that over here somewhere, and instead of referring to it as 100 lines of code, refer to it as 1 line of code, right? Like, if let's say that, you know, feed pet works, and it does in our case, right? Feed pet works now. So in a full program, I might never have to look at that code again, right? It worked, it's done. Right? So why ever look at it again? Just call it by feed pet. Right? All those lines up there are no longer, they're important to the program, but they're not important to me anymore. They're done. So let's abstract that away, put it somewhere else, hide it up there, and if I want to learn about it later, I can scroll back up here and find it. Right? It's not important to have that be all a bunch of lines in my main program down here. Right? The main lines of code. It's not important to have that all be taking up space down here. Very sick cheat code, I agree. When does Hitman start, by the way? Probably in about half an hour. That here goes. We'll be ending the stream very shortly, guys, and moving on with some Hitman Blood Money. We're like a gameplay stream here. We're a variety stream, really. We do some game dev throughout the week, a little more complex than this. We also do some fighting games like Street Fighter 3 Third Strike. Our current long play is Fear. That's First Encounter Assault Recon, an old school shooting game. We're going to do some Minecraft tonight and some Hitman tonight. But for right now, on Fridays, it's always Intro to Python from 6 to around 9 p.m. Eastern Time. Right now, it is at 8:40 Eastern. Okay, so we have these, you know, these functions up here now. Our first ever 2 functions, feed pet and play with pet. They've taken some arguments, so they need to do their job correctly. Right, some values. Pet's name has to know the pet's happiness level, has to know the pet's hunger level. And then we can use those values, those arguments inside of our function to get some jobs done. We alter them in here, like the pet's happiness level and the pet's hunger level. Then we return the new values back out so that the main program can access these changed values, right? What happens in a function stays in a function. So although we change these values inside of our function, that does not change anything outside of the function. We have to return the new data out to get some data out of this thing. So we're returning 3 parts for this first function. Whether or not we try to feed the pet rocks, and the pet's happiness level, and their hunger level. Right? So we're returning out of that function. Likewise, play with pet. Right? It takes in a couple of arguments here, and it returns the new levels of happiness and new levels of hunger afterward. Right? And down here, when we call these functions, we can record their returned values. We're calling it return values here, and we're assigning these returned values using the indexes. It's a multi-part value, right? This value has 3 different parts: the fed pet rocks, the pet's happiness, the pet's hunger. And we are assigning these values outside of the function now. So we're saving the data out of it, right? We called it using the arguments, right? The data we're feeding in. And we got some data out. And the data we got out, we are now saving under these different names, right? There you go. Then we're comparing here, if the pet's, full, it takes a shit, right? There's poop on the floor now, and it's hungry again, right, essentially. Okay, same with the play here. We ran the play function by giving it some arguments it might need. Then we're getting some values out of it and saving them. Right? Happiness and hunger, the new values, returned out of that function. We have some more activities here like quitting, cleaning, dagger code. And otherwise, our program's looking pretty sick. Not bad. So what did we learn today, guys? Let's go here to our notes. Take some notes here. Haven't done any notes yet today. So, today we made a lot of changes to our program without changing the way that it actually works at all, right? As far as the player is concerned, we didn't change anything. But what we did behind the scenes is significant, right? We made our code more elegant, right? That's a responsibility that you're going to have as a programmer as you become more skilled and more comfortable with programming, right? Oftentimes, making your program work isn't enough because it's going to be difficult for you to come back to that code, a few months down the line and add features to it because it's going to be hard to read. By making your code more elegant, you can make it easier to read and easier to enhance in the future. Right? So, how did we make our code more elegant today? Right? We took our main game loops logic tree, the series of if-else statements, which determine what happens in the game. And we broke it up into some smaller, more manageable pieces, right? This means that in the future, if we want to add new commands to our game, we don't need to constantly scroll through hundreds of lines of code just to find out where we want to make our changes, right? By putting all of the programming for feeding the pet into its own function, we can sort of encapsulate that code as being, distinct in purpose, right? All it does is feed the pet. All the data that it needs to feed the pet, it takes in as arguments. All the data that it changes in the game, it returns out, right? So it becomes very clear what data we need to know to feed the pet and what's being changed when we feed the pet, right? We do the same thing with the code for playing with the pet, right? By creating these functions, we make it more clear exactly what's happening in our main loop, right? When the player types in feed, we run a function for feeding the pet. If they type in play, we run a function for playing with the pet, right? We decided for now that the other commands were simple enough to not require their own functions to hide the complexity. Let's go demonstrate that real quick. No mean to interrupt you, says I Like Pops. But what's going on, Venka? I hope your day is straight, man. I'm gonna head out, just stopping by to say what's up. Good stuff, I Like Pops. I had an awesome day so far myself. I'm glad you are too from the sounds of it. Hope you have a good remainder of your night. Glad you could stop by and say hi. So we made two new functions, right? We made the feed pet function, the play with pet function up here, right? That entirely encapsulate their code for feeding and playing with the pet respectively. And then down here in our main loop, now we can say here, if you want to feed the pet, well then just feed the pet, right? If you want to play with the pet, well then just play with the pet, right there. 3 lines now. Right? Before it was like, like 30 lines. Now it's 3 lines. Play with this pet right there. Easy. If you want to quit, well, that's okay. You don't run a function for that. It's only 2 lines anyway. Right? Just quit like that. You want to clean up the pet? Well, that's fine. We can just clean the pet like this, too. Don't need a function. It's only a few lines. There you go. Dagger code, 2 lines. Otherwise, you know, you have an error message there. Here's the end of our function. Right? If pet's hunger is greater than 70, then do that. If poop on floor, then do that. You know, all this stuff. So-and-so can bite you if they're too low on happiness. It's whatever. Okay? So we made our function, although it works the same way, our program in general, it's more clean internally, right? For us as programmers. So we can add more features in easily in the future. We can now ignore this code here forever if we wanted to, right? Feed pet, it's done. Pet gets fed, no problem. If we wanted to change this code, but leave the other code the same, let's say that one day I wake up in a cold sweat and I'm like, yo, we need to have, you know, more hated foods. Right? We have 2 favorite foods, we need 2 hated foods now, right? Well, thankfully, oh, I just realized we have some more things that need arguments here. Anyway, we know that we can add that very easily because we have this, you know, little code block here that's by itself. You know, it's all totally isolated now, right? It's by itself. It's not related to any other code in the program. Just said, I want to change how feeding works. There it is right there. That's how feeding works. So it makes it easier for you to understand mentally, right? To keep things kind of straight in your mind. Right? We learned about tuples today, right? Let's go talk about that. Well, first, let's say here, you know, today was our first day creating our own functions. Right? Previously, we'd been using a couple of Python's built-in functions, including print, you know, which takes an argument to show on the screen, and input, which takes an argument to prompt the user with, and it returns whatever the user typed in. You know, in contrast, now let's just say that, you know, those functions are great, right? Those functions are awesome. But because our code is becoming more complex and longer every day, it became important for us to learn how to make our own functions as a way to separate our code into bite-sized chunks, and also to allow us to repeatedly execute code without having to type it 100 times. Right? We didn't really make use of functions that way today. That is a very important use of functions, guys. If you have a certain task you're doing again and again in your code, it makes sense to break it into a function and then call that function, rather than write the whole 20 lines over and over again. Functions take arguments to get data into them, and then because changes made within a function don't necessarily reflect into the world outside of the function. This is called scoping. We return some data out so that the program at large can then save that data over whatever values need to be updated. All right, so look at that real quick. So we have this, the play with pet, right? Playing with pet can change 2 things, right? It can change its happiness level. It gets happier if it's, if it plays, and it can also change its hunger level, right? Which is, if it gets more hungry after it plays, right? So we return these values back out. They might have changed. We don't know if they changed for sure. They might have changed. We're returning them back out, and then down here where we call the function, we save the old values, pet's happiness, pet's hunger. We're using the new values that we got out of this function. Right. We learned that if you want to combine multiple values into a single value, such as to return it, you can do so using a new data type called a tuple. Right? Previously, we knew about a few different data. Let's just say here, we know about 6 data types now. We know about strings, which represent textual data. We know about integers, which represent whole numbers. We know about Booleans, which represent true or false values. We know about functions, right? Which can be called to do stuff. And I guess we only know about 5. Boy, I'm gonna do this. We know about tuples, right? That's our 5th one we know about, I think. Right? Which are containers for other values, right? We'll say containers for multiple other values, right? For multiple other values, right? So tuples are interesting because you can access their data using index numbers. Right. For instance, if you have a tuple that describes an apple, it might look like this. Gala, 0.5, that's the weight. And, its color would be red. Right. Maybe you got it at the supermarket. Right. So it has this data referring to that apple, right, as a tuple. We have the type of the apple, how much it weighs, the color of the apple, and where you got it. Right. You can access the individual pieces of data in your tuple by using an index notation where the tuple name is followed by square brackets, between which are the index number for the value that you want out of your tuple. Right, like this. You can say, apple type is going to be, we'll say up here, apple equals, right? I'm looking at an apple tuple. Right. So the apple type is going to be our apple tuple. It's going to be the 0th slot, right? The first slot, aka index 0. Now, we talked about how in most languages, programming languages, the first slot is referred to as the index 0, right? We have the apple weight is our apple tuple in the index 1, or the 2nd slot. We have the apple color, which is the apple tuple index 2, or the 3rd slot. Then we have, bought apple at. That's going to be at apple tuple, the 4th slot, aka index number 3. Right. Kind of cool. Right. So that's kind of what we learned today, guys. We learned about functions. We learned about tuples. We learned about, we kind of reviewed a whole lot of concepts regarding, break, continue, different kinds of code blocks. Let's talk about next time, guys. I'm going to go down here and say that, for our next episode, we're going to learn about the differences between mutable and immutable objects. I'll say data types. Up to this point, all of our data types have been immutable, which means that once you define them, they can't be changed. Right? Well, right away, you're thinking, well, we've been changing a lot of values. Is pet's happiness immutable? Right? We've been changing it. Well, we haven't been changing the value, right? Right. We've been changing which value is associated with the name pet's happiness, right? By using the assignment operator, equals. Right? But the value itself has not been changing, right? We've just, been swapping values, for that variable name. All right, so let's look at that real quick before we call it into the stream, guys. So right here, for instance, right, we have this pet's happiness is 50, right? And here, we are changing that value. So it would seem, right? It says here, if you feed your pet its most hated food, then you subtract 40 from it. Right? So you're thinking to yourself, okay, well, we're changing that value, right? We're changing the value. So it's mutable, right? It can be changed. It can be mutated, right? It's mutable. Well, no. What we're doing here, actually, we're saying here, discard what pet's happiness level was. It was 50, right? Discard that and replace it with 10, right? So that 50 did not change. That 50, it was the value, and now it's not anymore. Now we have 10 instead. Right. So that's kind of counterintuitive, right? That's kind of counterintuitive. But it becomes more important as time goes on, because you're going to see situations where if you don't understand the difference between a value changing and a value being swapped out, it's going to cause problems with your code, right? For instance, we talked about arguments today, and return values, and how what happens in a function stays in a function. That's because when you feed an integer into a function as an argument, and then you change that integer, you are not changing the integer that you were fed as an argument, right? What you're actually doing, is replacing that value with something new, right? In the hypothetical case, which isn't going to be so hypothetical next week, that you were to feed a mutable object into a function as an argument, the function could actually change that value. And then, that change would be reflected outside of the function as well, because the actual value itself that was fed in was intrinsically changed. Right? It was itself altered in some way by the function. So that means that even outside of that function, that remains true, because the thing itself was actually changed in some way. Whereas to this point, guys, we've been using immutable data types, data that cannot be changed. It can only be replaced. If you replace it inside a function, then it's not going to, the world outside of the function does not have that new variable that you made. Right? You made a new variable inside your function, and so outside of the function does not have that variable yet. You have to return it outward, right? But if we were to get a mutable object, like an actual changeable piece of data as an argument, we could actually change it. We could change it and play with it and manipulate it. And then even outside of that function, those changes would be reflected because the actual object itself is being changed. But so far, right? So far, all of our data types are immutable. They cannot be mutated. And so whenever a variable name is being updated, its original value or its old value is being discarded, and a new variable is being made that just so happens to have the same name. Right? That's what we've been doing so far. Thank you, Echo Strike. I do a lot of typing, as you might imagine, as a programmer. How you doing, man? Not sure we've met. He has typed a midterm paper without breaking a sweat. I also kind of a little bit wordy. I apologize, guys. So we learned today about functions and tuples and other cool stuff. We're going to learn next week about how to use mutability. Right? We're going to learn next week how to use mutability to make our code even more elegant. And then we can start looking at how all of these improvements to our code's elegance are going to make it easier to add new features. Right? Through today's entire stream, we didn't really add any new features to our game, but we did lay the groundwork to make it more easy to add new features in the future. Now, once we discover mutability, we can dramatically improve our code's readability and, by extension, make it way easier to add new features and new segments and new characters and new items to our game. That's going to be for next week, though, guys, next Friday. So, awesome stream as always, guys. Thank you for hanging out with me here during Intro to Python. If you guys want to watch more Python tutorials, check out YouTube at youtube.com/Vencabot Archive. We're on Intro to Python Season 4 here, guys. Every season is 6 episodes, and every season starts off assuming you have never wrote a program in your life. It's your first program ever. And then by episode 6 of the season, we have a fully working game I'm pretty proud of. I think you guys are going to enjoy it as well. That's going to be, Season 1 as Pokemon. It's our Pokemon battle there. It starts off as what is a program, what is data, how do you make a Python program, and it ends with a fully working Pokemon battle. You can make your own Pokemon, make your own moves in 6 episodes. Then after that we did our adventure game. It's a text-based adventure, kind of like Zork, like a puzzle game. You explore a cave and you find items and unlock doors and solve puzzles. That was kind of fun. Again, episode 1 was very, very simple, first time programming ever. Episode 6 is a fully working game. Then we did an RPG last season that was kind of like a Dragon Warrior game, where you would go fight monsters and buy items. You'd get gold for killing monsters, go to a shop and buy stuff. That was fun. And this is Season 4, guys, where we're learning about this virtual pet kind of game. First day is now on YouTube. Episode 1 of Season 4 is how do I download Python? How do I write my first ever program? And now episode 3 is we learn about functions, guys. And episode 4 is going to be about mutability and how to use things like dictionaries and maybe even some simple objects. Maybe not classes quite yet, but some simple objects anyway. As usual, if you guys enjoy the channel, I want to keep it on. Check my Patreon page at patreon.com/Vencabot. I stream for almost 40 hours a week every single week. It's a lot of work, and when the stream ends, guys, we're going to stream all night long doing YouTube-type stuff and Patreon stuff and Discord-type stuff and programming to make the stream look nicer. It's a lot of work, and you guys help out a lot on Patreon in terms of making this sustainable, helping me buy gas and groceries and go to events like Michigan Masters, Texas Showdown, and Defend the North. If you want to help out for free, maybe you're like me, you're totally broke, you enjoy the channel, but you're not exactly, have the budget for helping a streamer out. That's awesome. In fact, the best way to help are all free. Get in the chat, come say hi. Makes it more fun for me as a streamer. Also, you can follow on Twitch for free, tell your friends we're here, save clips of our gameplay shows, and check out YouTube again at youtube.com/Vencabot Archive, or just search on YouTube for Vencabot. You'll find tutorials on there for Python, lots of gameplay, fighting games, online type stuff, multiplayer. I'm very proud of that. It's a lot of work, though. I'm going to go for a short break, guys. Come right back with some Hitman Blood Money. I will see you guys very shortly. Every week, guys, on Friday, we do Intro to Python tutorials from 6 to 9 p.m. Eastern. Right now, it is 9:07 Eastern Time. We're a variety stream here, though, guys. We only do tutorials one night a week on Fridays. Every other night, we do mostly gameplay. We're going to do some gameplay here very shortly, Hitman Blood Money, followed by Minecraft later in the evening. If you guys like Hitman or Minecraft, definitely feel free to hang out here. If you're only here for the programming, by all means, have a good night. But the stream don't stop. We're just changing our topic. No, the only one that had problems was Pet's Happiness, Kenny. I'll bet you I mistyped it. If you watch the VOD, I bet it was Pet Happiness instead of Pet's Happiness. I don't see why else it wouldn't have worked as a global. So I thought for sure that that would work as a global, and every other one did. Pet's Hunger worked as a global. As did as did the pet's name. Yeah, when you use the global keyword, Kenny, all you're really doing is defining a global inside of a function. So you're saying here, even though I defined it in the function for the first time ever, I want it to be global outside of the function. But if it's defined outside of the function, it's already a global. You don't need to use the global keyword outside of a function. And you don't need to use the global keyword inside of a function just to use a global. It just means you're defining a new global inside of the function.
Fuck.
Dagger says, do you like any other Python libraries? Hell yeah, man. I like a lot of them. I just try to avoid them for the most part on Intro to Python because it's really more about vanilla syntax and data types and stuff here. Obviously, for larger programs, you use a lot of libraries. My most used ones are probably like Socket. Also, I like to use threading, random for games a lot, obviously. Time for sleep, date time, very useful. So Echo says, I'm having trouble with discoverability in Python. In C# I can just type in class or method, and IntelliSense shows all the methods and parameters with some detail. But in Python, I found that to be really iffy. I'm not sure what IntelliSense is. Is that your IDE, my friend?
Yo, punch this dude! Oh, that's that! Oh my god.
Perhaps IntelliSense doesn't support Python that well. Because by your example there, it should work fine and with Python or any language. A drop-down list of all available methods or the required parameters. Yeah, it should work fine. It works fine in idle here, which comes with Python. Also, it works fine in things like Eclipse. So perhaps your IDE IntelliSense just doesn't support Python that well. It should have no problem giving you the methods and parameters.
Oh my god! No, my god!
If those methods, if your classes work.
Oh my god! Yo, Mexi! Yo, Spyro!
Which would be more help, sir. But yeah, it sounds like it's something going on with your IDE.
The smile of a winner!
Oh my god.
If your classes are mistyped, if they're not actually syntactically correct in Python, that would be a problem. But if they're syntactically correct and they're actually your program actually runs just fine with those classes, there's no reason why your IDE shouldn't be able to give you the methods and the arguments and stuff. Are you using the underscore notation Echo Strike? I can see how that might hide certain methods.
Just see what just happened. Please tell me you just see.
You shouldn't need to use dir class. Again, Python internally is standardized such that methods and attributes that begin with an underscore are meant to be private. So those ones might be hidden by default in IntelliSense for all I know. That could be your problem.